Good evening. We're here with the DES, and we are going to get started in a few minutes. We have about a third of the registrants so far, so we're going to let some more people join us before we get started with the full presentation. All right, it looks like people joining is starting to slow down. It's actually going backwards, so I will get started. So good evening. First, I wanted to thank all of you for attending this evening, and thank you for the opportunity for the DES to give you this PFAS update. I'm Amy Rousseau, and I'm the PFAS Response Administrator for the DES. Part of my position is that I oversee the PFAS initiative across the different programs within the DES, and I administer the funds that help those initiatives take place, as well as I administer some funding options that are PFAS specific. But more importantly, I am a resource and a point of contact for all of you, and my contact information will be presented as we go through this presentation. So to start, I want to go through just a few housekeeping items. So this meeting is being recorded. All attendees are muted upon entry. If you're having any technical difficulties with the platform, which is GoToWebinar, Erin Holmes, it will be our technical assistant tonight, and her email address is erin.holmes, so ERIN.HOLMES @des.nh.gov, or you can reach her by phone at 603-271-8321. I have included some handouts as part of the platform. You'll see on your dashboard there is a handout section. If you click on that, there's 5 different handouts. One is the slides from the presentation with all of the instructional slides removed, and then there's some fact sheets, some procedures for sampling, and a few other things for you. These handouts will also be available after tonight's meeting. So as part of the follow-up email, there's going to be a link in that email that you can get all of those 5 handouts, as well as the recording of this video. We will be taking questions at the end of the presentation. Anyone that has called in tonight by phone is in listen-only mode. And so they will not be able to communicate with the platform or the panel, and they will not be able to ask questions. If there is a question that you would like to ask and would like to register and be part of the GoToWebinar platform, please reach out to Erin and she can assist you with that. To ask a question, we are asking that you use the question function on your dashboard to be added to a queue. To do this, you'll see over here, this is the dashboard. If you can't see it on your screen right now, you might see just this small sliver of a section that has a right-facing arrow. You want to click on that right-facing arrow and it should open up your dashboard. There will be a banner that has questions. If you click on that little white arrow, that should open up the question box, and then you can just, we're asking that you put your first and last name and your town of residence in that enter box right there. We're asking for the town of residence because we are sure there are others besides Bedford residents in attendance tonight, and then click send. We are asking that you do not type your question into this box. When it comes to the question and answer period, Erin is going to go through some further instructions on how it's going to work, but you will be able to ask your question live as we will unmute you so you can ask that question. All right, now I'd like to go through some introductions. So I have with me tonight, first, Mike Wimsatt. He is the Waste Management Division Director, and he will be going through some background information on PFAS. I have Jonathan Ali. He's our toxicologist with the Environmental Health Program, and he'll be going through the health effects. Jeff Martz is here with us. He's a senior hydrogeologist with the Hazardous Waste Remediation Bureau, and he'll be going through some site investigation, sampling, notifications, results. And then we have Brandon Kernan, and he is the administrator for the Drinking Water and Groundwater Bureau. He'll be addressing two different subjects. So he'll be going through public water system status, as well as what a homeowner can do to mitigate PFAS contamination. And then we're going to go over to Erin Holmes. She is the Drinking Water and Groundwater Trust Fund Administrator. She's with the MTB Remediation Bureau, and she'll be going through some funding options that are available to help with some potential solutions. And then I will be moderating the question and answer session. And during the question and answers, we will also have Amy Doherty with us. She is the State Site Section Supervisor with the Hazardous Waste Remediation Bureau, and she'll be able to answer questions on PFAS outside of the St. Gobain consent decree area. And then Kathy Beam is also with us, and she is with the Air Resources Division. So with that, I'm going to turn it over to Mike Wimsatt. And Mike, I am going to give you sharing, keyboard and mouse. You should be all set.
Great, thank you, Amy. So good evening, everyone, and I want to welcome you to this meeting. We're really excited to be here tonight, and we really want to focus our efforts on answering your questions and talking to you about things that are important in your community. But in order to do that, we also want to make sure that everybody who's participating tonight has kind of a common understanding of the basics of what PFAS are and how we got to where we are tonight. So I'm going to try to spend just a few minutes giving you a brief description of really defining what PFAS are for those who don't already know, and then talking about a little bit of the history of how we got to where we are tonight. And this problem in southern New Hampshire, I think many of you know, started back in March of 2016. That's when our discovery of it occurred. So we're 5 years into this, and there's a lot that's happened and a lot yet more to come. And we want to try to help you understand that this evening. We've got a pretty, Amy just went through a pretty long description of, of our agenda. And I want you to understand that what we're hoping to do is keep that within an hour. We want to make sure that we give you a lot of helpful information here, but we really want to make sure we have plenty of time left to answer your questions, and we're looking forward to doing that. So with that, I will begin. And there it goes. So what are PFAS? So PFAS is a mouthful. It stands for per and polyfluoroalkylated substances, which is a lot to say. These are a big family of compounds, thousands of them actually, that are all synthetic. They are all man-made. They do not occur in nature. And basically, it's a carbon chain that contains many fluorine atoms that are bound to it. And the two that are really most studied and ones that we've been dealing with mostly in New Hampshire are perfluorooctanoic acid. So you'll hear that referred to as PFOA or Pifoa. And then perfluorooctane sulfonate, which is PFOS or Pfos. But again, this is a large part of a much larger group of compounds. And I want to talk a little bit about the nomenclature just so that folks understand what we're talking about. So this is sort of our family tree of PFAS, and you see the two lowest branches. There's the polyfluoroalkyls and the perfluoroalkyls. And all that means is if it's a perfluoroalkyl, it means that on the carbon chain, every available bonding site has a fluorine atom attached to it. And if it's a polyfluoro, it just means that a lot of those bonding sites have fluorines, but one or more of them has a different atom. In many cases, that might be a hydrogen atom. So that's maybe more than you want to know. That's the difference. And you'll see this sort of the apple that fell from the tree on the bottom here called PFC. That stands for perfluorochemicals. And that really is the same as this perfluoroalkyls. But it's a terminology that has kind of fallen out of favor because it is not as inclusive. And there are some PFAS compounds that we have concerns about. We don't have regulatory standards for them yet, but ones that we are looking at that are in the polyfluoro category. So that's why we try to use this more inclusive nomenclature of PFAS. So, and then here on the tree also, you see actually 4 of the compounds that we regulate. We'll talk about that a little bit later. And then an additional one. So this is just a way of sort of orienting you to what the nomenclature is. And then, what I think many folks already know is that these compounds, they were first developed in the late 1940s. They have been used and applied in so many different both commercial and retail products and industrial products. And the reason is that PFAS compounds have a very unique characteristic is that all at the same time, they can resist greases and oils, and they can also resist water. So that's a very valuable and uncommon characteristic for one chemical. And as a result, they have many, many uses in industry and in retail. And so, as many of you know, the contamination that we are talking about tonight is primarily sourced from the Saint-Gobain facility in Merrimack that emitted these through the air. And that would fall in the category of basically these textiles, because much of what they manufacture is coating various fabrics with Teflon-related products that use these PFAS compounds as a means of getting that attached to the textile. But as you see, there are many, many other products and materials that these have been used in. So I want to talk a little bit about the discovery of Pifoa in contamination in southern New Hampshire. So as I said, this goes back to 2016, and in early March of 2016, Saint-Gobain reported results of water tests at its Merrimack plant. And interestingly, the first results they got, they had other plants in other states where they had already identified that they had this air emissions problem. And so they looked for the problem at their Merrimack plant. And what they actually tested was publicly supplied water from the Merrimack Village District. And I think it was in bubblers in their facility. And when they tested that, they found 30 parts per trillion of Pifoa. So they immediately notified us. And then we took immediate steps to do sampling of public and private drinking water supplies in the vicinity of the plant. That moved very quickly, and we started finding it in places that really surprised us. We found it, we actually sampled across the river, the Merrimack River in Litchfield, and found it in private wells on the other side. So very quickly, this airborne transport pathway became evident to us. And so that launched a monumental effort of sampling. We started sampling very rapidly and to evaluate the impacts to drinking water. And of course, a number of communities were impacted, and Bedford is one of those communities where, as we expanded our sampling, we began to find impacts in private and public drinking water wells in a number of towns, including Bedford. Sorry, Jesus. Okay, so what this launched for us was an incident response unlike any other the agency had ever really attempted to make. We were doing a massive outreach and sampling effort. We had staff from all over the agency who were going out on nights and weekends and all day long, knocking on doors, sampling private wells. We had, used a lot of tools, including our geographic information system capabilities and mailings, telephone, as well as the door-to-door. And as we found many private wells that were impacted by this contamination, we provided bottled water initially through, collections or just bringing pallets to the local fire station and that sort of thing. And then eventually setting up a delivery of bottled water through a contractor. But the long-term solution obviously was going to be getting alternate water provided, because the impacts were so significant and so widespread that we realized that extending public water to people who had previously been served by private wells was really going to be a significant part of the solution to this. So there were a number of very large-scale waterline projects that were funded by the responsible party, by Saint-Gobain, that were designed and constructed, and hundreds of residents in these communities who previously were served by private wells, have been connected to public drinking water systems. And in Bedford, that was true as well. There are private wells that have been connected to both public water systems operated by Pennachuck using Manchester Waterworks water, as well as through MVD using the Merrimack Village District's water supply. And there's still more sampling going on in Bedford that you'll hear a lot about tonight, and alternate water planning that we'll be doing now and in the future. So I want to talk a little bit about the consent decree. You'll hear about that. So as we were doing this work, about coming on 2 years into this work, we realized we had enough information, we had sampled enough wells and gotten our arms around what we thought to be the extent of contamination at the then standard that we were using, which was 70 parts per trillion. And we were negotiating with them because we really wanted them to work swiftly to design and construct these very large waterline projects. These were multi-million-dollar waterline projects that really needed to get underway. And as we negotiated a consent agreement to get them to do that, and basically as part of that consent agreement, we established some zones around the facility. And I want to go to the next slide. So on this slide, you'll see that's just an aerial picture of the actual facility, which is located right in the center of these two strangely shaped objects here. So the inside line is what we call the pre-GMZ, or a pre-groundwater management zone. And what that is we use the concept of the groundwater management zone when we're dealing with contaminated sites to describe the area of groundwater that's impacted above standards. And so we knew that we had a lot more work to do. We weren't going to be able to draw that line with any accuracy as part of this agreement. So we called it a pre-GMZ. And the idea was that that was an area where inside that we were pretty confident that most of the water that we would sample would be above that 70 part per trillion standard. And then the blue line that you see surrounding that is what we call the outer boundary. And I want to talk a little bit about what those two things mean. So as part of the consent agreement, within the pre-GMZ, or that red line, basically the state retained all its authorities, the agreement provided that Saint-Gobain needed to essentially provide drinking water and extension of public water systems to virtually anybody who needed it within the pre-GMZ. So that was pretty clear. And then, again, it's easier to almost talk about this, what's on the inside, what's on the very outside, and then we'll talk about the middle. So outside the blue line, that limited Saint-Gobain's responsibilities outside that outer boundary to impacts that were over the 70 part per trillion standard. So that meant that as we expanded our sampling and did more sampling, if we found wells that were above 70 parts per trillion, we could there would be an expectation that we could request and require that Saint-Gobain address those impacts. But if there were impacts below that, and that we wanted something done as a result of setting a lower standard at a later date, we were limited in our ability to request or to require Saint-Gobain to do that. So then if you talk about the space in between, you want to call it the donut, so the space between the red and the blue line, the state there retains all its authorities, and basically, because we didn't have as much sampling done at that time in that area, we said we're going to continue to ask you to do sampling, and where we see impacts that we believe are attributed to the facility, we're going to ask you to address those. So we have our full authority to hold you to what the requirements of the law would be. And so as we've done this work, we have learned, we'll talk a little bit about how the standard was lowered. So as we've done this work, we have determined in a number of communities, including Bedford, that we do have some impacts above our current lower standard that are outside the blue line. So that creates a little bit of a problem because we're not in a position to compel Saint-Gobain to address those impacts. So we're going to be working with communities, including Bedford, to figure out what we do with those particular results. So let's talk a little bit about the drinking water and groundwater standards. So very soon after we discovered this, we knew that back in 2016, we knew that EPA was studying PFAS, particularly Pifoa and Pfos, and trying to evaluate its existing standard for basically protecting people who are drinking water. And at the time we first discovered it, they just had a guideline that was on the order of, they were basically using around 100 parts per trillion. But the work that they were doing, we wanted them to really complete soon because we had this emerging problem. So we encouraged them really strongly to finish that work, which they did. And they recommended that 70 parts per trillion be the standard for both Pifoa or Pfos or the two combined. And so we immediately adopted that standard through an emergency rulemaking process in April of 2016. And that became our ambient groundwater quality standard that was an enforceable standard for the site and for the impacted properties. And then as we reviewed this work, and we got some directives from the legislature to evaluate and establish new standards for these compounds. We did some work to evaluate the new science and the emerging science, and we discovered that we really needed to have a lower standard than 70 parts per trillion, and that there were individual standards for each compound that we wanted to set. So we proposed a rulemaking that became effective in September of 2019. Unfortunately, that rulemaking was immediately met with a lawsuit from 3M and the Plymouth Village District and some other parties that basically sought a preliminary injunction. So the Merrimack County District Court, or Merrimack County Superior Court, did impose a preliminary injunction that became effective in late December of 2019. So those enforcement of those standards was delayed. And then through House Bill 1264, which sought to make those standards effective as a matter of law, that bill was passed and signed by the governor in July of 2020. And so since July of 2020, we've had these new, both ambient groundwater quality standards and drinking water maximum contaminant levels. And those are separate for the 4 compounds that are involved. So we have, I apologize, for some reason I don't always get the slide to advance. There we go. So for Pifoa, we set a standard of 12 parts per trillion, quite a bit lower than the original 70. For Pfos, it was set at 15. For perfluorohexane sulfonic acid, or PFHXS, we set it at 18. And for perfluorononanoic acid, or PFNA, we set it at 11. And the MCLs are, and the HQS differ in the sense that the MCLs are standards that we apply to regulated public water systems. In the ambient groundwater quality standards, and they're one and the same as far as the number goes, but they apply to how we address impacts to water at contaminated sites. So that's a whirlwind tour, just to give you an idea of what PFAS are and how we got to where we are today. You're going to hear a whole lot more from folks specific to your community, and we'll all be back together at the end of this presentation to field your questions. So with that, I want to turn it over to Jonathan Alley, who is our toxicologist, and he's going to speak with you regarding exposure, health risks, and common concerns associated with PFAS. John?
Okay, terrific. Thank you. Can you hear me? Okay. So give them a second to give me control over the slides. Okay, so I just want to give a little background on the program that I work in at DES. I'm part of the Environmental Health Program, which it sits in the Department of Environmental Services. But in this program, we also work with federal partners at the CDC through a special grant called AppleTree. It's probably the world's longest acronym. But we also work with the Division of Public Health Services at the New Hampshire Department of Health and Human Services. So if I don't address all your questions in this presentation, or if you have other questions for me that are appropriate for those partners, I'll be happy to try to get that information to them or connect you with them. So to start with, how are you exposed to PFAS? So these are chemicals that we can find in the environment, including drinking water. And the primary route of absorption, or the primary way these get into your body, is through either drinking contaminated water or consuming contaminated food. So basically, if you're ingesting it, that's the best way to get these chemicals absorbed into the body. They can also transfer across the placenta and into fetuses, and they can also transfer into breast milk. So if someone has been consuming contaminated water or contaminated foods for a long period of time, they're likely transferring it to their offspring. There are several studies that have shown that for several decades now, most people have been born with some level of PFAS contamination within their blood because of how persistent these chemicals are. There's also potential for inhaling or ingesting these through certain PFAS-containing dust, so this can contribute to exposure. So this can be environmental dust, like contaminated soils, but it can also be dust from household products. So as Mike went over before, a lot of these chemicals have been used in historical products like Scotchgard, water stain repellent, clothing, fabrics, upholstery, and over time, these can generate dust that can be inhaled, or in the case of infants, if they're crawling around the floor, they can be exposed through hand-to-mouth behaviors. Most PFAS, to our knowledge right now, it does not appear that longer chain compounds, or the ones that we're regulating for, are well absorbed across the skin. There may be shorter chain compounds or different ones that are not currently regulated that may have better absorption across the skin. But at this time, most studies have looked at exposure situations like firefighters that come in contact with firefighting foam, which is several orders of magnitude higher concentration than what we expect to see in water supplies. But one of the chief concerns that we have for these compounds is they're called bioaccumulative. This means that when you get some of these into your body, they can build up over time. So when we account for that in our drinking water standards, that's why our program recommended the numbers here that are current HEQS and MCLs. These were developed trying to account for how bioaccumulative these compounds are. That's why a small amount matters. So while ingesting a small amount won't have a direct impact on your health tomorrow, it will accumulate and it'll take years to get it out of your body. And that could be years that the chemical could be having an effect. So the standards that we developed are intended to protect pregnant and lactating women and their infants, those same individuals who consume a lot of water on a daily basis, and those same individuals who have had chronic exposure over several years to several decades. So this is the most sensitive end of the population that we identified, and this is the group that we're protecting. That's one of the reasons our standard is lower than that set by the EPA at its 70 parts per trillion. And in addition, this number accounts for that fact that you may still have some exposure to these chemicals from other sources. So it might be items like certain seafood can contain PFAS, certain food products may still contain it, and some food packaging may contain it. So for more technical information about how these standards were actually derived and some of the risk assessment science behind that, I've provided a link in this webpage. Now, one of the things that people often ask is, what are some of the health effects? And this is a constantly evolving area of science, but some of the key effects that have been associated to PFAS include increased cholesterol levels, changes in liver enzyme levels. So if you get a regular panel of blood work, that would be like your AST, ALT levels. There may be smaller subtle changes in infant birth weights, alterations in immune system function, potential risk for preeclampsia in pregnant women, alteration in thyroid hormone concentrations or other hormones such as testosterone or estrogen. And some studies have suggested that there may be an increased risk for kidney or testicular cancer, This has only been identified in certain populations that have had significantly high exposures. This is, again, an ongoing area of study. So the Agency for Toxic Substances and Disease Registry, which is a branch of the CDC and National Institute of Health, is conducting a nationwide study to try to understand what the impacts of these chemicals are on people. They've also included populations from Pfas and the greater Portsmouth area in New Hampshire. So they're also looking across the country so we can try to understand where the impacts of Pfas when we account for different lifestyles. This is a constantly evolving area of research, so there's always new studies and new articles that are coming out about it. It can probably make your head spin if you try to Google it. There is information on ATSDR's website about these chemicals and some useful links to read up if you're looking for additional information. So now I want to go over some commonly asked questions that I've been getting on phone calls from residents from Bedford, Merrimack, Londonderry, and other parts of New Hampshire. So one thing is, if you're concerned about your health, where can your physician learn more about PFAS and your family's risk? So there is physician information available at the New Hampshire Department of Health and Human Services website. They've previously sent out basically a notification to physicians to share this information with them. ATSDR, or the Agency for Toxic Substances and Disease Registry, also provides guidance for clinical practitioners. Again, this is an evolving area of science, and this is actually the subject of a National Academy of Science panel that's currently evaluating if this guidance should be updated or changed. Another frequent question that we get is there a test to measure the amount of PFAS in your blood? If these are accumulative chemicals, if you are consuming them from your environment and they can build up in your blood, you can measure them. So yes, there is a test, but it is a very complex issue. In New Hampshire, the same law that passed and codified our MCLs and AGQS as standards also required health insurance companies to pay for PFAS blood testing. So it is available. Your physician will probably be unfamiliar with this, so you'll need to be patient if you go to ask them for this service. Another warning that we always try to provide people is there's currently no clinical guidance to change course of treatment based on someone's PFAS results. So you may be able to get a number, but it will not change your current course of care. So it's really important to discuss this with your physician based on your health history, your needs, and what their concerns are for you to determine if this is appropriate for you and your family. And again, if you need more information, or if your physician needs more information, they can use the links above, or if they just want to give me a call, if you want to give me a call, I'll connect you to the information. Some other common questions. Can I cook with the water if I can't drink it? If your water is currently above our MCLs or AGQS, we do not recommend that you cook with that. We recommend you find an alternative source of water. You cannot boil these chemicals out. So if you're heating up the water on the stove, hoping that it'll cook out, like if there's a bacteria warning, sometimes that's not how this works. It will not reduce the amount of contaminant in the water, in the food. And additionally, if you cook certain things like pastas or protein items, it could actually concentrate in the food and increase your exposure. So in that case, we do not recommend cooking with it. Can you use the water for bathing, showering, or cleaning? Our standards are based on ingestion or use as drinking water, because that's the primary way these chemicals get into the body. There's very, very limited evidence that the 4 compounds we regulate for have significant absorption across the skin. But if you have concerns about that or concerns about your results, you can always call our department. We'll try to help you interpret those. But in general, it's up to sort of residents to make that determination, as we do not have a safe level determined for skin contact, because skin contact is less significant to exposure than ingestion. Similarly, can I irrigate my home garden with fruit, or irrigate home gardens and fruits and vegetables? Again, these standards are meant for drinking. There's very little science, and it's an evolving area of research to understand how these chemicals might be taken up into certain crop items. The 4 compounds we are regulating for are typically poorly absorbed by plants. There's a different set of PFAS compounds that may have greater absorption into certain plant products, but that's difficult to predict because we don't really understand what they're doing in New Hampshire soils. So again, these are not standards for gardening, but if you have questions about this or would like more information, we're happy to share that information with you and the studies that are available. Following on that is the same idea of irrigating your lawn. So if you're irrigating the lawn, do you possibly have residues of these compounds out there? It is possible, but again, we don't expect significant amount of skin contact or exposure to be occurring with that. And secondarily, if you're applying any other chemicals to your lawn or products, you should be mindful about those if you're also going to be having contact there. We do have a standard, or at least a guidance number for assessing risk in soils, which is available at this link here. There's more information about that. If you want help understanding that, we're happy to have a call. Oftentimes I've had people call asking me about pets. The standards are based on human health protection. They're not developed for non-human animals. So that includes canines, cats, dogs, frogs, fish. I've had a couple interesting veterinarian calls. In general, you should speak with a veterinarian first to see if there is a health concern for your animals there. And if they're wanting more information to try to make a specific assessment based on your animal's health history, we're happy to share information and studies with them. And then finally, as Mike mentioned, this is a class of thousands of chemicals, but we only have standards right now for 4 of these. At this time, we do not have standards for the other set of chemicals that may be detected out there. Some of this is limited by which chemicals can even be measured in the environment, and some of this is limited by occurrence. And our program tries to prioritize chemicals that we are detecting within the state or detecting at high amounts to try to see what we can do to assess their risk and prevent exposure in the public. So with that, that is my contact information. I'll be around at the end of this to answer more questions. If you can think of anything else, feel free to shoot me an email, give me a phone call. I'm happy to call people back, business hours, funny hours, whatever you need. Thank you. I believe I'm going to hand it over to Jeff now.
Thanks, John. Good evening, everybody. Thanks again for attending our talk tonight on PFAS. Again, my name is Jeff Martz. I'm a senior hydrogeologist with the Hazardous Waste Remediation Bureau. I'll be talking about PFAS sites, drinking water sampling, and PFAS occurrence in Bedford. The Hazardous Waste Remediation Bureau, which I'm part of, is tasked with providing regulatory oversight into the investigation and remediation of contaminated sites involving PFAS. So that's our role here at DES. So my first slide is a slide showing the town of Bedford outlined in yellow. The surrounding towns are shaded blue. There's an air photo backdrop so you can get a rough sense of the land use in Bedford. And this map shows known PFAS sites. And as Mike mentioned early on, the release from Saint-Gobain is related to air emissions, and that's why we're talking about PFAS in Bedford with respect to Saint-Gobain. And this map shows the portions of the pre-GMZ that Mike described, shown as red. This is the area where primarily the waterline extensions that Saint-Gobain funded occurred within this area, encompassed by the red portion of the pre-GMZ. And then the outer boundary of the consent decrees, the blue line, runs roughly through the center of the town of Bedford. And then you'll notice that there are 2 discrete PFAS sites, and these differ from an air emission site in that the nature of the release tends to be a little smaller and a little more focused. And in the case of the 2 sites that are shown in Bedford, the Nashua Road property and the Bedford landfill, these are both sites where PFAS have been detected in on-site groundwater monitoring wells, and the responsible parties are investigating, whether there are impacts potentially off-site near these sites. There's another location in Bedford that does not have a known source of PFAS right now. We're investigating several possibilities. That's the Bedford Center Road area, located right at the center of town, near 101, just outside of the consent decree area. That's something Amy Doherty can answer questions on. So I work with Amy Doherty. She's the state site supervisor for the Hazardous Waste Remediation Bureau. And just to talk a little bit about our division of labor in HWRB, so I'm managing the Saint-Gobain site investigation. So I'm responsible for fielding questions from areas within the part of Bedford that are inside the blue outer boundary area, and Amy Doherty is generally fielding questions pertaining to sites or well sampling outside of the consent decree in Bedford. I know we had some questions from residents ahead of time about some other sites, so I'll just walk you through quickly. The new Boston Air Force Station, there's been some PFAS detections that's located outside of the town of Bedford. And then the Merrimack landfill is located right on the southern border of Bedford and Merrimack, and there are some residential wells that have been impacted adjacent to the landfill. And finally, I'll just point out the Saint-Gobain site just so you have a reference. And it's roughly about 4 miles from the Saint-Gobain facility located in Merrimack along the Merrimack River to the center of Bedford. So that's a roughly 4 mile distance. So, you know, we're talking about air transport of the PFAS a considerable distance. So I'm just going to walk you through briefly this air emissions pathway. So this is a cartoon figure depicting the Saint-Gobain facility where they do textile coating, as Mike talked about, and they basically take rolls of textile, dip it into a chemical mixture, and then that fabric proceeds up into a oven where it's heated. The exhaust from those ovens comes out the rooftop smokestacks, and PFAS have been shown to be emitted from those stacks. And the PFAS travel with wind and are dispersed over an area, and they fall to the ground as either dry particulate deposition, or when it rains, the PFAS may dissolve in rainwater, land on the ground that way. And as it rains, the PFAS leach through from the ground surface into the soil, and they slowly work their way down to the water table, which can be either in fractured rock or in soil overburden. And once they're in the water table, that contaminated PFAS water could be drawn into water supply wells. Well, tonight's talk is primarily focused on groundwater quality, water quality, drinking water quality. I do want to point out that Saint-Gobain is required to install air pollution controls, and there's a deadline for that by July 30th. We do have Kathy Beam on the call, and she'll be able to answer any questions related to the air controls or air emissions at the end of the talk during the question and answer session. And I do have a few links that you can find from the handout to get a little more information about those air controls. So there are 5 primary sources for PFAS sampling data in Bedford. The first I'll mention is Saint-Gobain. They are responsible for evaluating the extent of ambient groundwater quality violations inside the consent decree due to discharges from their facility. They submitted a work plan to initiate this work in September 2019 when the standards that Mike discussed first went into effect, the lower standards, when the standard dropped from 70 parts per trillion for PFOA and PFOS combined down to 12 for PFOA. After the initial work plan was submitted, Saint-Gobain and their consultants have submitted 8 addenda to NHDES. Each of these addenda contain new lists of properties for the next round of sampling. And the 9th addenda is expected by the end of May. Saint-Gobain's consultant, Golder Associates, submits biweekly updates and bi-monthly reports to NHDES, and these are all publicly available on our one-stop database. Second source of sampling is NHDES. NHDES is prioritizing sampling based on the potential for risk of contamination of wells. So there's 3 general categories in Bedford of risk prioritization. And the first is notification sampling. I'll talk a little bit later on about the notification program, but basically properties within 500 feet of a known ambient groundwater quality standard exceedance are eligible for sampling from NHDES free of charge. A second area is the Bedford Center Road area, which I mentioned, which is just outside the consent decree in the Route 101 area. There's properties there that have been identified for additional sampling to investigate some unknown or not yet fully investigated sources of PFAS. And third, there are a subset of wells within a half-mile beyond the consent decree boundary are going to be sampled to evaluate potential impacts in that half-mile buffer beyond the consent decree boundary to see if additional sampling is warranted. And you can sign up on the NHDES webpage to indicate willingness if you'd like to have your well sampled. And I'll talk about that a little later on also. The third group of data that come into DES are from residents who self-sample and then provide the results to NHDES. And it's important to note that all of the data that I'm showing is data that either DES or have been submitted to DES and are available in our GIS files. You know, if residents, it's really important if residents sample their well and find that they have an AGQS violation for them to report that to DES so that we can address it and provide the notification to surrounding properties. The fourth group of data comes from discrete release sites that I talked about on the first slide, and that's where responsible parties do required investigation and routine sampling of any potential at-risk water supply wells or on-site monitoring wells. And finally, the fifth source of PFAS data is coming from public water supplies that are required to do certain testing. And Brendan Kernan will talk a little bit about this later on in the evening. So here's a map of Bedford, and I am showing the results for the compound PFOA, perfluorooctanoic acid. These are represented by the color scheme in the lower part of the slide. And I've chosen to represent PFOA for the remainder of my talk, primarily because PFOA is the one of the 4 regulated compounds that most frequently exceeds the ambient groundwater quality standard. So I think it's helpful to symbolize that, and we can talk through that. So I'll just call your attention to the color ramp that I'm using, and I use this throughout. So anything that's shown as green is a groundwater sample that tested between 0 and 6 parts per trillion, so at 50% of the ambient groundwater quality standard. 6 to 9 is colored yellow, 9 to 12, so right up to the standard, is orange. And then anything that's over the standard of 12 parts per trillion for PFOA is red. And then if it's above the former standard, 70 parts per trillion, I've colored it purple. So as we mentioned earlier in the night, Saint-Gobain funded waterline extension primarily within the pre-GMZ area. And if you look, with only 1 or 2 minor exceptions, almost all of the purple identified circles, so samples that tested above 70 parts per trillion for PFOA, are located within this red pre-GMZ boundary. As you step away from the pre-GMZ, sampling indicates a variety of different results, ranging from non-detect up to over the standard of 12 parts per trillion. And in total, across the town, approximately 809 wells have been sampled for PFAS. 719 of those are inside the consent decree and 90 are outside the consent decree. So we have 90 primarily up in the center of town and in the southwest portion of the town. Of the wells that have been sampled, 317 samples exceed ambient groundwater quality standard for 1 or more of the PFAS, and the vast majority, 301 of those, are located inside the consent decree area in that portion of Bedford, and only 16 wells that we have as of April 30th outside the consent decree exceeded the ambient groundwater quality standard for PFOA or one of the other 3 compounds that are regulated. So now I'm going to step into the consent decree and talk about the sampling program that Saint-Gobain is implementing. The map in the upper right portion of the slide shows the overall consent decree, which is a 64 square mile area that's under investigation. This includes portions of several towns, and the portion of the consent decree area that's under investigation in Bedford is highlighted in this central map here. And what you see is kind of a complex mix of colors, and I'll just briefly walk you through what those colors indicate. And also point out that the lots are depicted by these light gray lines, so each little parcel there is represented by those gray lines, represent the various lots in town. So lots that are color-coded dark green or are confirmed to be connected to public water. So those are properties that are served by public water systems. There are light blue colored lots which may be connected by public water, but in any event, they are thought to be adjacent to an existing public water line. The brown colored lots are properties where Golder has requested permission to collect a sample. In some cases, they have collected a sample and that data is available. And in the case of the brown lots, if they did collect a sample there, the results are below the ambient groundwater quality standard. Conversely, the lots in this area that are colored pink are properties that have been sampled and the results of the sample are greater than ambient groundwater quality standards. And those properties have been offered bottled water. The blue hatched lots are the most recently identified lots that have been added to the sampling program. So with each subsequent addenda, there's a new set of blue hatched lots which represent the new addition to the sampling program. And one of the takeaways when you look at the totality of this figure is that a little more than half of the properties in Bedford are either A, connected to public water or proximal to public water, B, have been invited to be sampled or were sampled, or C, are about to get letters, or have received letters for sampling in the case of these blue hatched lots. The lots that don't have any shading have not yet been incorporated into the sampling program. And the sampling program is really driven by risk. And I'll talk a little bit about that on the next slide. So one frequent question that I get from residents is, why was my property selected for sampling? And this is a blow up of another figure from Golder. Same shading applies. And they've added in the actual triangles and circles representing wells that have been sampled for PFAS. Wells that tested below the standard are colored green, and the wells that exceeded standard on the pink colored lots are colored yellow. So there are basically three reasons that properties were selected for sampling, or generally three reasons. The first is proximity to a known ambient groundwater quality standard. So when a well exceeds ambient groundwater quality, adjoining properties or nearby properties are added to the next addenda's sampling list. And starting with addenda 9, expected by the end of the month, the criteria to identify the adjoining properties is going to be a 500-foot buffer drawn around the well that was sampled and was found to be above standard. The second category is what I would call a quasi-random selection of properties in areas where we have limited PFAS data. So for example, these two properties here at this arrow are not particularly close to any other wells that have been sampled, and that's trying to start to fill in the gaps in the map and try and figure out if we have other hotspots around. So we're doing this random sampling. Or Saint-Gobain's consultant is proposing properties for random sampling to try and gather that data and fill in the gaps. And the third category, which is relatively new in the last few addenda, is neighborhood scale identification. So entire streets or segments of streets involving several contiguous lots are added to the list for sampling based on Golder Associates, which is doing the work on behalf of Saint-Gobain, their analysis of the data and where they think the sampling has to go in order to achieve that risk-based sampling approach. In other words, sampling close to proximity of known PFAS contamination in groundwater. And just want to point out that in that 64 square mile area, we're literally talking something on the order of 4,000 to 5,000 wells that need to be sampled. So it's a substantial lift. They can't all be sampled all at once. So it's being done in this risk-based, data-driven fashion. So as I mentioned, properties that exceed ambient groundwater quality standard within the consent decree are being provided by alternate water from Saint-Gobain in accordance with the work plan that was submitted in September 30th, 2019, when the standards first went into effect. And basically, the bottled water is considered an interim measure until such time as a permanent solution can be provided by Saint-Gobain to affected parties. Examples of permanent solutions include extension and connection of public water lines, or potentially entire house treatment systems or point of entry treatment systems. And Brandon's going to talk about this a little more in detail later on tonight, what those treatment systems might look like. But those are the two main likely remedies inside the consent decree area with respect to Saint-Gobain. So as Golder Associates does the sampling for Saint-Gobain, and they detect a sample that's above standard, they send a package to the affected homeowner, and that includes an excerpt of the letter that I'm showing here on the right, which is an eligibility to receive bottled water letter on Saint-Gobain letterhead. Golder Associates also transmits the lab results with a cover letter and a summary table, and I'll talk about that summary table. I'll show you an example later on. But the takeaway, just to draw your attention to start the bottled water, contact Nathan Curtis and his phone number here. He's one of the managers at Monadnock Spring Water, and I'll talk about this on the next slide. So this is a slide that Golder Associates provided at DES's request that walks through the steps on obtaining the bottled water. We get a lot of questions from residents about the bottled water process. So bottled water should be provided, fairly quickly upon you contacting Monadnock Springs. So the way the flow chart is, when Golder detects a sample that's above standard, they provide letters to the property owner and also simultaneously copies letters to Monadnock Spring Water. The property owner can choose, they can also decline to accept the bottled water, but if they choose to accept the bottled water offer, they can contact Monadnock Springs to coordinate the delivery. And the property owner has been asked to monitor their inventory and notify Monadnock Springs 2 to 3 weeks before additional water is needed. And property owners are reminded to advise all occupants about using the bottled water for cooking and drinking. And this is particularly important in the case if it's a rental property or there are other tenants in the building that might not be aware of the testing that was done. So the map on the bottom right of the screen shows PFOA results for a section of Bedford with a topographic relief map in the background. Topographic relief is a useful tool for geologists to evaluate hydrogeology and get a sense of topography. But what this map shows is that there's a very complex spatial distribution of PFAS in groundwater, particularly in Bedford. This is common throughout Bedford outside the pre-GMZ area, where we see a high degree of variability such that one person's well can be over the standard and the adjoining wells can be below standard. So I get a lot of questions as to why this is happening. And I think there's some major factors that influence what we see in the subsurface with respect to PFAS concentrations at individual wells. And the first being differences in air deposition. So this yellow to purplish pink figure is just an excerpt of an air modeling that was done by NHDES for PFOA emissions from the Saint-Gobain facility. So the yellow colors represent areas where higher deposition of PFOA is thought to have occurred, and grading on into lower concentrations of PFOA that were deposited over time, denoted by these sort of cooler purple colors. So closer to the source, more PFOA was thought to have deposited, and in general, as you go further from the facility, the amount of PFOA deposited on the ground surface dropped off. This next map that's sort of underneath the air modeling image represents the Surficial Geology, which are the soils or unstratified material above the bedrock. And in a lot of cases, these are highly influenced by the last glaciation. We have tills, stratified drifts, and lake deposits. And the reason I mention all these is because when PFAS and groundwater that dissolves the PFAS start percolating through these soils and these different deposits, the PFAS have a tendency to sorb or stick to some of the soils. And the nature of the soils are thought to be one factor as to how much PFAS sorb. The thickness is a factor. And I think there are a variety of other variables that are under investigation by scientists in this area of study. And next, and importantly, is the bedrock geology certainly influences the variability that we see in groundwater, and I'll talk about that on my next slide. And lastly, the time-related factors, such as changes in the chemicals released over time, precursor transformations, which involve chemicals that are often longer chain compounds or different compounds that break down into the 4 compounds that we regulate. And finally, seasonal variation, so changes in the amount of rainfall, temperature, and various factors that have influenced the hydrology. So one of the common questions that I also get is, why do neighboring wells have such different concentrations of PFOA? Or why is my well over standard and my neighbor's is not, or vice versa? So I think to get at the answer to that question, we have to talk a little bit about how bedrock wells work and how they're drilled, and talk about the evolution of PFAS along a flow path. So when a well driller goes to drill a well, they pull a drill rig onto a property, raise the derrick, and they start drilling down. And the first thing they do is drill through the soil and a little ways into bedrock. And if they kept going, eventually they'd have soil washing down into the hole. So they have to put a sleeve to permanently stop or protect the bedrock wellbore from having soil fall down into the hole. So the black portion of these slides represent the well casing going down into the ground. The well casing, you can see the part that sticks out above the ground often is black, or it has different colored caps. And before talking further, I should mention that this is a cross-section or profile view. So we're looking at a slice through the earth through 2 wells. So we're looking down what could be 400 to 600 feet below the ground surface. So this drawing is not quite to scale, but it should be about 400 feet down is a common depth for many wells in Bedford. Some go deeper. The brown colored areas, the soil or the surficial deposits that I mentioned earlier. So that's unconsolidated material over the rock. And then as a driller, once the driller gets the casing in place, they continue drilling down through the rock until they encounter water-bearing fractures, such as the one shown in the photograph on the left-hand side. This is an actual photograph from a well taken by a special downhole camera. We're looking down the well, and you can see the rock wall. This is probably a 6-inch well, so we have about 3-4 inches of view here. And what you can see are streams of water entering the wellbore from fractures in the rock. So this picture could easily have been taken from the example well that I show on the left side of the profile, relatively shallow fracture. So on this profile, I'm depicting water-bearing fractures as dark blue lines. So these are the cracks that are full of water. So as the driller goes, they drill until they hit a fracture that produces either enough water, or they keep drilling until they hit a series of fractures that produce enough water to sustain a normal residential use. Or in some cases, they don't hit a lot of water, but they'll continue drilling deeper and at least establish a storage in the well. So for every foot in a 6-inch well, you have about 1.5 gallons of water stored. So to get back to the story of why I think we see differences in PFAS from wells that are adjacent to each other, we need to think about the flow path of how an individual drop of water goes from the land surface and into each well. So in the example on the right-hand side, presumably these wells are very close together, maybe 20 feet apart, and the amount of air deposition is assumed to be relatively uniform at this neighborhood scale. And I've depicted that by these red arrows. So again, drawing your attention to the color scale. So the red arrows correspond to water that would test between 12 and 70 parts per trillion. So as we get away from the pre-GMZ into middle of Bedford, or in between the pre-GMZ and the outer boundary, we find a lot of wells that are in the greater than 12 category. So I use that as an example of the water that's infiltrating into the soil. Now, as I mentioned before, as PFAS travels through the soil, some of that may sorb to the soil, and the concentration of PFAS as it moves through a deeper soil column may actually diminish to the point where you have water entering the bedrock fracture that's actually below the standard of 12 parts per trillion. So I've depicted that as the orange line going through the fractures and goes into the well. And in this example well, it's hit 2 fractures, a second deeper fracture, which may either not contain PFAS or it's less than 50%, so I color coded it green. And when the pump turns on, it draws water from both fracture zones into a mixture, and that resulting mixture is lower than the concentration in the middle fracture, and is pumped from the well at something like 6 to 9 in this example, nanograms per liter for PFOA. By contrast, the well is drilled higher up on the topography here. The well is situated in a place where the soil is thinner, so the soil doesn't have that ability to filter out the PFOA to any extent. So the PFOA that goes through the soil, makes it into the rock, is getting into the well and is still above standard. So this well, when it pumps, is pumping water that's over standard. So this is just one example of the many different factors that can influence PFOA concentration in residential water supply wells. So the notification program that I mentioned, so DES is required by statute or state law to notify property owners within 500 feet of a well with an AGQS violation that's reported to DES. So if DES gets the lab report and is notified, we have to send a letter within a certain amount of time to property owners. And I've got 2 example letters here. You don't really need to read them for the purpose of this talk, but one is formatted for inside the consent decree and the specific criteria that pertain to that location. And the example on the right is for properties that are outside the consent decree. But what they both have in common is that they include contact information if you would like to have your well sampled, who to contact. So it's important if you get one of these letters, read it carefully and follow the contact information provided. So now I'm going to talk a little bit about an example lab report, or in this case, this is a summary table provided by Golder Associates to residents inside the consent decree. And more often than not, residents are just having a difficult time trying to interpret this because there's just a lot of information being thrown at them. And understandably, this is something that I look at day in, day out, but it's clearly complex and not readily known to most people. But Golder's put together these tables to try and summarize the lab 20-page lab packet that comes with the information and onto one page. So when I talk to residents with questions, I talk them through this table, and I've highlighted sort of the important takeaways that it's important to look at. So the first important takeaway is I've highlighted in yellow the 4 compounds that DES regulates. So that's PFOA, PFNA, PFHXS, and PFOS. And it's easier to talk about the acronym for these compounds than to say the big long names. So I usually talk in acronyms. The next thing to point out is the ambient groundwater quality standard that Golder puts on this table. So in the case of PFOA, that's 12, for PFNA, 11, 18 for PFHXS, and 15 for PFOS. So the next thing to look at when you have one of these lab reports is to go to the results column, which I've circled in red, and to compare the result with the ambient groundwater's quality standard. So in the case of PFOA, the result in this example was 66 parts per trillion, and parts per trillion are equivalent to nanograms per liter when we're talking about residential well concentrations. So in this case, the 66 parts per trillion is greater than the 12 part per trillion ambient groundwater quality standard. So in this case, the water sample would violate the ambient groundwater quality standard for PFOA. Another thing to point out is that some of the notation used in this table for other compounds that are not detected is to put a number with a U after it. And the number that's reported here with the U after it is what is called the method detection limit, or the minimum amount of a chemical that a lab can detect in a water sample. So laboratories can't measure down to 0 when they're looking at parts per trillion. So there's some minimum number that below which they just really can't say, if it's there or if it's not there. So in this notation, they're saying this sample has PFNA at something less than 0.47 parts per trillion. So a very small number, it could be 0, but it could be something less than 0.47 parts per trillion. Briefly, here's another example lab report. This was a sample that resident collected, submitted to a private laboratory and got it back, so it's not summarized by Golder. So this does not include the ambient groundwater quality standard that I mentioned, so you would have to look those up or remember them from this talk, or look them up on the DES website. But in this case, you look at the results column. This particular lab report only had the 4 compounds that DES regulates. Some have 20 or even up to 30 compounds, but in this case, there's only 4. It's probably a little less expensive. And you can see in this example, PFOA exceeded the standard of 12 parts per trillion by about 14.4 parts per trillion. So it's just a little bit over the standard. And the notation that this lab uses to indicate that a compound wasn't detected is the acronym ND, which stands for not detected. So a little more simple than the U, or a little more intuitive. So finally, I just want to point out a few features on the PFAS website, because there's a wealth of information there. You can either get there through this link at the top, which will be available as a handout, or I usually just type it into my search engine as NHDES and then PFAS, and it's usually one of the top search hits that come up. So once you get to the page, you know it by the steel well casing in the foreground, and then we have a menu across the top. And under the PFAS in drinking water, there's information on private well testing, the NHDES form that you can sign up if you're interested in having your well tested. And there's also information on Pfast treatment technology. Under maps and data, there's an interactive map which shows the GIS data that have been uploaded to the state, and you can look up your neighborhood and see what wells have been sampled in your area and what those results are. You can actually click on the points and see the actual values. There's a frequently asked question page. And then if you scroll down a little bit, there's a running blog which goes back probably to close to 2016 that has important milestones for the project or newsworthy events. So those are for PFAS in general, the state of PFAS regulations, as well as St. Gobain in particular. There's a lot of posts. And if you don't want to keep coming back to the website, if you scroll all the way down to the very bottom, there's a place where you can subscribe for email alerts. So you can sign up, and anytime there's a new blog posting posted, you'll actually get an email in your inbox, and then you know to go back and check the website. So I think with that, I believe that's my last slide, and I will turn it over to Brandon and take questions at the end. Thank you.
All right, thank you. So I'm going to go over a couple of things tonight. First of all, I want to go over the status of sampling at public water systems, and then secondly, I'm going to talk about how homeowners can test their wells and also implement treatment for PFAS and other contaminants of concerns. First of all, I want to talk about the public water systems. And in Bedford, people get water from 2 sources, either their own private residential well, and that's primarily what Jeff March just talked about, or they get it from a public water system. And in Bedford, we understand about 30% or 40% of the town would get its water from a public water system. And so I just want to explain what a public water system is. A public water system is something that's regulated by both the federal and state government, and you determine if a certain system is a public water system by sort of going through this decision chart here. And so the first question you ask to figure out if the water supply is a public water system is, does that system serve at least 15 connections or 25 people at least 60 days a year? And if the answer to that first question is yes, then you are some type of public water system, and you'll see in a minute there's 3 different types of public water system. If the answer is no, then you're a private well and fall into the category that Jeff primarily was talking about. And then, so once you find out if you're a public water system or not, the next question you ask is, do you serve 25 people or more who live on site year round? And if the answer to that is yes, in your community water system, and so that could be like Powder Hill in Bedford, or English Woods, or areas served like Camp Preserve or by Manchester Waterworks. They're serving homes, same people that get the water every day and reside in that dwelling. And so that's a community water system, and that's the most highly regulated type of water system, a community water system, the place where people live and get their water from. If you answer no to that, then you could be one of two other types of water systems. You would ask, even though you don't live there year round, do you serve the same 25 people or more at least 6 months a year water? And if the answer to that is yes, then you're considered what we call a non-transient, non-community system. So that'd be like a school or an office where people don't live there, but they're there a lot and they are exposed to the same water over and over again. So that's also pretty highly regulated and a little less so than community water systems, but pretty substantial sampling requirements, including for PFAS, like the community water systems. If the answer to that is no, then you're considered a transient water system, and that's the least regulated type of public water system. And that could be like a gas station that has a beverage bar or a restaurant where you're serving people every day, but presumably it's different people, not the same population every day. And those systems have the least number of regulations they need to comply with and don't have to sample for PFAS currently as a public water system in New Hampshire. Although, as you'll hear about in a minute, the state is sampling those systems one time at least. So just an overview of public water systems in Bedford. This map shows the town of Bedford. And the triangles show sources of water for one of the three types of public water systems I just mentioned. So it could be like English Woods, a community water system where people live. It could be some of the businesses that you see here where they may have the same 25 employees. They might be a non-transient water system, or it could be a transient water system, where you have just a few employees, but different people from the public coming in every day, such as the Animal Rescue League. And so this just shows where there's sources of water for public water systems in Bedford. Sorry about that. It gets a little more complicated in Bedford because in addition to those sort of standalone public water systems I just showed you, those triangles, you actually have water supply lines coming into the town from both Manchester and Merrimack. And so on the bottom here, you'll see Cabot Preserve, and it's pipelines that serve subdivisions of homes, and they're getting their water from Merrimack Village District, so they actually don't have their own well. And similarly, you have like Little Pond Estates and Powder Hill that are their own water system, but they're getting water from Manchester Waterworks through connection. And so while they have their own name, their own water system, the water actually comes from another water system. So in addition to those standalone systems, you have these water supply lines that are coming into the town from outside sources. Now, to give you an overview of the PFAS sampling results for public water systems in Bedford, we've summarized results that we have available to date, and there's about 20 results for the community water systems and the non-transient water systems. So the community being, again, where people live, the homes, and subdivisions, and the non-community, non-transient being things like schools and offices. And then we have a couple transients actually in this list as well. And of the results, you can see we have exceedances at 6 of the systems, or had at least exceedances at 6 of the systems. And you can see the population served for each one. But some of these have already been addressed. For example, Camp Foster, which had an exceedance a few years ago, has installed treatment. And so they're actually drinking water that has non-detect or very low levels of PFAS because they put in reverse osmosis at their drinking water sources at the facility. Or you can look down at another facility, Ironsides, that is not active as its own water system anymore. It's no longer that triangle you saw on the map, but it's actually connected to a larger water system. And so they would have much lower and compliant water quality data at this point. And there's other scenarios, such as a school that's currently not active or doesn't serve more than 25 people, that no longer is a public water system. And so while we have these exceedances on the map, many of them have been addressed or the status has changed over time. There's a number of systems in Bedford that are going to be sampled in the next month or two. Those are the transient water systems. Those are the systems that don't have to sample and to demonstrate compliance to the PFAS MCL at this time, because again, they're serving presumably different people water each day, and not exposing the same population to the same source of water. But nevertheless, the state is going out and sampling all the transient systems over the next year. And we started so before COVID. It got slowed down due to COVID and complications with logistics, but it's starting up again. And so we'll have additional data for these transient water systems over the next couple of months for Bedford. So that's sort of a summary of the PFAS and public water systems. Next, I want to talk about in-home water treatment options for homeowners. And as I go through this, obviously we're here tonight to talk about PFAS. But when we talk about private wells, it would be very erroneous for us to just focus on PFAS tonight. While PFAS is a man-made contaminant that has dramatically impacted southern New Hampshire and needs to be addressed, and will be addressed in the talk tonight, New Hampshire private well owners have other challenges that aren't related to this man-made contaminant. To do with natural contaminants in the environment or other possible on-site sources of contamination. Just things like arsenic, which is naturally occurring in our bedrock and a big problem in New Hampshire and very toxic, needs to be addressed. Bacteria and things like nitrate and nitrite are possible issues with well construction or contamination from on-site sources like manure piles or septic systems and things like that. And then you have a number of other contaminants, such as manganese and lead and copper and chloride, that has numerous sources, both environmental and possibly on-premise sources that need to be addressed. And so it's kind of pointless to just focus on PFAS if you're a homeowner with private well, because if you're going to be looking at treating your water, you want to address all these exposure concerns and just not the PFAS, which is a new wrinkle because it wasn't in the environment until it was released there. So our recommended steps to private well owners in Bedford, and really for anyone, and this is advice I even follow for my own well in the Lakes region where I live, is to test your water for the compounds you see here. And to get the results, and go to our website called Be Well Informed, and you can enter in your results, and it's really easy for people that don't have even a background with water chemistry to use the site. And this site will then proceed to analyze your water to tell you where your water quality is relative to standards for each of these constituents. And if necessary, it will also show appropriate treatment trains to holistically address your water quality in a logical order, so that you can ensure that for all these compounds here, that you're making sure exposure is being eliminated at your home. And so this is just a screenshot showing the Be Well Informed site. It's quite easy to find on the internet. Be Well Informed, New Hampshire will usually get you there. And then you click on this green bar to enter your well test results. I'll just caution you, if you use this site in the next week or so, some of these links are broken. The state or the Department of Environmental Services completely redid its website, every single page. And while we worked really hard to update it and make it a much better website, and it is, we still are fighting some broken links that we are working with our contractors on fixing. But this bar does work and you can use the tool. But if you need the additional information and the link is broken, just contact us in the interim and we'll get you that. It will be no problem to fix that issue. And so this is an example of the screen where you'd enter in your data based on the lab report. It has constituents and you can match the units to what you see on the lab report, similar to what Jeff showed you. And again, we can help with this. The tool is updated to include PFAS. So it both has the natural contaminants and the man-made contaminants that we're concerned about. And here's an example of what you get out of this tool. You get information about the results that you enter relative to state standards, and it tries to provide it in a real interpretive way where you have a graphical indication on is your water quality safe to drink or not, and then the message telling you what standard it's approaching or exceeding. The red is where you have an exceedance, the green is where you have water quality that meets standards, and yellow is where you're approaching a standard that you might be concerned about and either want to proactively treat or keep monitoring to make sure you understand what the value is consistently. And the output will also give you something like this. Now this is just based on the hypothetical sample that I entered, so this will be different for each homeowner, but it'll actually point out, based on your water quality, a treatment train approach for addressing exceedances that you might see. And in a logical way, you can't just put these treatment components on in any order that you want to. There's a certain hierarchy on filtrating contaminants in the water so that you have efficient removal and also protect the filter media and optimize its performance. And so we encourage homeowners to do that if it's not already. And you don't need a sample for everything, although that's what we're recommending. Even if you only have partial results, you can enter that into the tool and it'll give you information, obviously void of the constituents that you haven't sampled for. Now I want to talk a little bit about water treatment options. And again, this tool would point to specific options based on your water quality, both for PFAS and non-PFAS contaminants. But first of all, I'll just point out that we do have a fact sheet on Pfast treatment on our website. As I pointed out, you really need to pay attention to traditional contaminants. You know, a lot of people are using carbon to treat PFAS, and that's very effective for PFAS, but that doesn't do a thing for arsenic or uranium or nitrite. And so you really want to make sure you have the whole picture before you invest in a treatment system. When you look at treatment, there's a couple options. Something that's very feasible and easy to do is a point of use system. We call this quote unquote under the sink. It could really be in the basement under the kitchen option. And this is where you're taking a stream of water from your cold water plumbing system and sending it to a dedicated faucet after it's been treated. And there's a couple options for treatment. One is reverse osmosis, which is what I actually use in my home. And that removes not only PFAS, but most other contaminants very effectively. And I'll get into that a little bit more in a minute. And then there's also a point of use option for granule activated carbon. Again, if you're just focused on PFAS or maybe another compound like a volatile organic compound, you would look at just granular activated carbon for point of use. We have something else called point of entry. It's often referred to as POE. This is something that would treat the water for the whole house. Granular activated carbon is usually the option for PFAS. You would not use the reverse osmosis that I talked about on point of use for the whole house because it would waste a lot of water and potentially overwhelm your septic system or dewater your well. Granulated activated carbon is great. I'll point out though that it's not an off-the-shelf product like these point of use systems are. You can easily go online or to even a big box store and find these point of use systems. The point of entry treatment system is something that you need to often have a plumber or water treatment specialist sort of put together and buy the basic components and build it. Just a caution though, if you're treating all the water in your house for PFAS using granular activated carbon, it'll remove the PFAS very effectively for quite a while, but you need to understand that it could build up radionuclides, specifically radon, in the treatment media. And so if you have high radon, you would not want to have a carbon filter filtrating water for a long time without replacing that media because you could create a hazard by building up radon in the filter media. There's another option for point of entry that's not commonplace yet for homeowners. It's engineered resin, which does a really good job at removing PFAS. The challenge at the homeowner scale is that it has to be regenerated with steam and you have to store a waste product, and that's not ideal in a home setting. But at some point they may come up with an approach to make that more commonplace for a home. But engineered resin like granular activated carbon is very effective at treatment. This is just an overview of what the point of use reverse osmosis system is. It's something that fits under your kitchen sink, or a lot of people actually put this in their basement on a shelf somewhere below the kitchen, and you can see this thin tubing which can go to a dedicated faucet on your kitchen sink, and also can be split off to your refrigerator for water or ice making as well. These units are, you can see them easily, as I mentioned before, at the big box stores. Cost $200, $250 if you buy them there online. If you pay someone to install it, it'll probably be more like $1,000 to $1,200. But professional installation is ideal for a lot of people. The system's pretty straightforward, where you have a sediment filter that immediately treats the water as it comes in to remove any particulate matter. Then there's some pre-treatment with carbon, and then it goes to the reverse osmosis. And the way this filter works is there's a lot of pressure here that's trying to push water through a membrane, and only the really clean water gets through, and then the reject water would go to your wastewater system, which involves having an air gap if you're connecting the plumbing to the wastewater system. And then after it's treated with the RO, it's pretty clean at that point, but most systems still have a polishing carbon unit. And then it goes to a small 2.5 gallon tank that will provide water to that dedicated faucet. That would be a separate faucet on your kitchen sink and also could be split off to your refrigerator. So it's pretty straightforward. Filters have to be replaced for the carbon and sediment, often every 6 months to a year, and for reverse osmosis for every year to 2, depending on how much water you're using. And to replace filters on your own, it's less than $100 a year, and to hire someone would probably be a few $100s, given their overhead expenses and expertise. A point of use carbon system, again, is pretty similar to the reverse osmosis, where you have a dedicated treatment system for a faucet on the kitchen sink. You would have your well water coming in, your cold water line, and then you would again have a sediment filter to remove particulate matter. And then most of these systems would have 2 carbon filters to provide redundancy, and some would even have a sample tap in between. So if you could see if one carbon filter was wearing down or being expended, you would know to start replenishing that. And then it goes to a dedicated tap. These are both, I guess I could say, they're not only to dedicated tap, there are systems for carbon that also will go to your cold water, existing cold water faucet in your kitchen sink as well. But again, this is just carbon, and it's primarily be removing PFAS and not addressing those other contaminants that we should be concerned about in New Hampshire as well. This is a picture of a point of entry. This is, again, a system that would treat all the water coming into your home, and being carbon, you'd primarily just be focused on PFAS. Again, it's not addressing the other contaminants I mentioned earlier. It won't remove those. But typically, you have these vessels that are 3 to 4 feet high, 15 inches in diameter in your basement, and it would take water from your pressure tank and treat all the water going into your plumbing system. And so you would have redundant filters again with a sampling tap in the middle, so you can start seeing when the first filter is being worn out. And then all the water in the home for all fixtures would be treated. Often people will install this and bypass outside faucets that are used for irrigation just to preserve the treatment media longer. Just a couple things to caution you is that treatment does work really well, but you really need to do the testing before you can have confidence that it's working. Treatment directly affects water quality, and if something was installed wrong, you could have adverse water quality. It's not common, but it's something you need to be concerned about. Also, especially if you're using carbon, it's important to test your water for even things other than PFAS, because some carbon, if it hasn't been rinsed adequately, can initially put off arsenic into the water just based on where it comes from in the environment. It's naturally occurring. And while it'll flush away eventually, you don't want that exposure. And so you need to make sure the vendor is pre-rinsing the carbon and that you're testing your treated water for not only PFAS, but for other constituents. As far as how often you should really keep testing your treatment systems, that's kind of site specific. It depends on the concentration of PFAS coming in to your home and the type of treatment system that you have, how robust it is, and what redundancy you have. So it's really a site-specific question. Testing is recommended both on the raw and treated water, and if you can afford to do so at the midpoint of your treatment system, if you have redundant filters, like I showed in the picture before, 2 carbon filters, and also final. That way you can track how much life expectancy you have remaining in your filters. But some people find it not feasible to do so, and will just test the final water quality over time and track trends that way. Almost any treatment system requires a sediment pre-treatment filter just to remove particulate matter. And people should be alarmed when they look at this filter and see red and brown and all that. That's all very normal. It happens everywhere in New Hampshire, just not where there's PFAS contamination. There's quite a bit of particulate matter in water, and if you put a filter to it, you will capture something that looks like stained material, but that's natural, and that would even happen to filters with public water systems in many cases. And for how long these filters are effective, there's some studies on the website I referred to earlier that talk about EPA's assessment of these filters. generally for several months and up to 2 years before requiring filter change out is what we're observing so far. In some cases, when systems have been over-designed, the filter has to be changed out just to prevent bacteria from becoming a problem in stagnant media over time. And just some resources on where you can get guidance on testing your water for PFAS. The Be Well Informed site has resources for labs for non-PFAS testing, and then links to our treatment. And again, some of the links on the website are broken. Just contact us if there's something you're looking for, and they're all being worked on and fixed as we speak. But the website's new, so it's a little bit of catch up there. And I appreciate your time. Thank you.
Just want to make sure I've got the mouse control here. Okay. Good evening. Thanks for hanging in with us for this long. And I am the last speaker, and then we'll be taking a little break. And during that break, I'll give instructions on how to ask questions, and then we'll roll right into the question and answer session. But I just wanted to talk about some of the financial assistance programs. Again, my name is Erin Holmes, and I'm the Drinking Water and Groundwater Trust Fund Administrator here. But really, myself and Amy Russo are going to be your primary contacts for financial assistance programs. There we go. And really, the main takeaway is a lot of these programs are geared towards various types of water systems, and Brandon showed a really comprehensive slide about the different categories of the public water systems. So just bear that in mind, that when I'm talking about this really is applicable to different levels of types of public water systems. But right now, one of the biggest takeaways is you'll see there's several financial assistance programs that are established, and they target these various types of public water systems, as well as some financial assistance for all schools and child care centers. The second takeaway is these financial assistance programs range from helping a small community water system with their decision making. Maybe they're faced with some contamination above the MCL for PFAS, and they're trying to figure out if they should move forward with adding treatment to their system or interconnecting if there's an option of a larger system that does not have PFAS impacts, all the way up to large-scale drinking water infrastructure projects, such as putting on treatment or a new supply well, or even some interconnections. So there's a big range of the types of programs that we have available for this. And obviously, everybody listens to the news and have heard a lot about the federal stimulus funding coming. Within the state, we are working to figure out how that monies will be used and what programs they're going to be really shepherded through for the drinking water related funds. So those funds could become available and put towards addressing the PFAS impacts of drinking water systems, public water systems as well. Just don't have a lot of information on that I can share with you tonight. And then finally, the final takeaway, and I know this probably isn't the best one you want to hear about, is right now, for those residents who are outside of the consent decree area, there really is no funding mechanism right now for treatment or bottled water of your private well. And I think Jeff Martz did a really good description of what Saint-Gobain is doing within that consent decree area, and it is specific to those areas within that blue line. But unfortunately, outside of it, there are no funding mechanisms at this time, but that doesn't mean that they can't be and they can't be envisioned, because as I'll talk about some of these programs, they could be applicable for different avenues. So I just wanted to make that known. And then the other takeaway I don't have on here is really working with DES. Between Amy Russo and myself, we can point an entity, some type of public water system, and even talks that we've started with the town of Bedford in the Bedford Center Road area to figure out a solution and the funding programs that would be available in there. You know, DES, we're very well versed. We are the experts on helping find these funding programs and seeing what you can fit into if you need to address an issue. So that's the real takeaway, is talk to us and we'll work through it with you. So the primary funding sources, when I talk about, include the PFAS remediation loan fund. And I say primary funding sources because these are the ones with the most amount of funding. The PFAS remediation loan fund has about $50 million in the appropriation, and this was established in the statute, that can be used for eligible water systems. And when you think of Brandon's slide, we're really looking at that upper tier, those community water systems and nonprofit, non-transient community water systems like a school. But there is eligibility criteria that the project must meet, but it is a low interest loan program and allows for principal forgiveness for small systems that might be disadvantaged and meet the criteria. But the best thing about this loan fund is there's a contingent reimbursement. And so if an entity, or let's say a community water system, is adding treatment for PFAS to their wells, they can use this loan. It's a low interest loan to fund the project. But then if there is any monies that the state wins through our lawsuits against the manufacturers of PFAS, there's a potential for a reimbursement of a portion of that loan. And we don't have a timeline on that, but it is available. So it is a really attractive option for a community water system that needs to address PFAS in their well, or add treatment or interconnect. And then the other option that really, again, considered primary option is the Drinking Water and Groundwater Trust Fund. And this fund still has about $153 million in the corpus account. The funding decisions are made by a 19-member Drinking Water and Groundwater Advisory Commission, so that's very important. While DES can assist a water system or a municipality with their application and work through all the requirements and really how to put forward a good project, we, DES, do not make the funding decisions for the trust fund. It would go in front of the commission, and then DES would administer that program. But the real important program that we have for drinking water related projects, contamination related, is coming in as a special project. And so there's no deadline, you can apply at any time, and contamination related projects are still viewed as the primary concern of the Drinking Water and Groundwater Advisory Commission. So it's very important to evaluate, loan programs, and this is also a loan and grants can be administered through the trust fund. So a lot of options there. And then just to kind of talk through some of the programs that we have established, some of the entities out there, people listening, these might apply to what you have, or if you have a PFAS issue. And the first one is there's a PFAS design services grant reimbursement program, essentially. So this is applicable to all schools and child care centers. There's about $800,000 in appropriation. That money was put in as a budget item, and it actually comes from the Drinking Water Groundwater Trust Fund, but it's administered by Amy Russo. And what this does is provide about 26% of the total project cost, really focusing on the design requirements to put on treatment and to address the PFAS issue for these schools and child care centers, as well as transient and non-transient public water systems. Next, kind of along that same lines, is helping a system make some decisions. We have a consolidation study assistance program that's funded by the Drinking Water and Groundwater Trust Fund. This is up to a $10,000 grant to evaluate treatment or to interconnect and consolidate your water system with a larger viable system that does not have a contamination issue. And it's really focusing on those small community water systems and nonprofit, non-transient, non-community water systems like schools, again, and helping these entities that don't necessarily have the capital on hand to do a full evaluation of, do we want to put on treatment and have long-term operation and monitoring costs and the headaches and the hassles and the costs associated with that, or if we have a viable system that is, if there's a feasible approach to connect to, maybe that's a better option. And a lot of these small systems don't have the money and the capital on hand to just help them make that decision. And that's really why we, DES, stood up this program and proposed it to the Advisory Commission, who saw a lot of value in providing this for these small systems. And then getting into, I already talked about the loan fund again. So, now we're getting into, you've done the evaluation, you've figured out what your most feasible option that's effective for treating, and you have to do a drinking water infrastructure project. And that's really where you would come to Amy to talk about the PFAS remediation loan fund. And then along that same lines, the Drinking Water and Groundwater Trust Fund, as I talked about on the previous slide, is trying to put together a loan or grant program, or loan or grant for the water system or for the municipality to come up with a solution to address the issues that they're dealing with. And something just to really highlight is, those first three programs, there has to be an exceedance of a PFAS MCL to apply and be eligible for these programs. But they're geared to helping the community and helping them find a solution. And I think that is a really important takeaway, that, we, the state, have spent a lot of time investing in developing these programs and making them available. And as I mentioned, Amy and I are there to help you and navigate through to see how you would apply and what programs would be applicable for you. And I have one more slide. This is just for the reference, the slides will be shared. These are relevant links about the programs that I just discussed, and you can click on any of these links and find eligibility information, applications, and contact information as well. All right, so with that, the panel is going to take a 5-minute break, and I am going to sit and talk to you about how to ask questions as we get ready for the question and answer session. And I see there's about 99 of you still listening and paying attention. And so because of that, I just want to go over some ground rules, and then I'll talk to you how we'll manage the questions and answers. So Amy showed you the slide at the beginning, and I'll show you that after I get through these two slides. But just as a reminder, any of these instructions I'm giving are only applicable to those who have come in on their computer or on their phone through an app, and they're not applicable to any of our telephone-only attendees who are in listen-only mode. We are unable to see you or unmute you. And if you do have questions, I recommend reaching out to, you can reach out to members of DES, the names that you've seen or that you've heard here, as well as the members of your town who put this meeting on. They can provide you our contact information as well. And we're happy to answer any questions or concerns you might have. So to ask a question, you'll need to use the GoToWebinar question function. Using this function, you will let DES know you would like to ask a question by entering your first and last name and the town you are from into the GoTo question box. Please do not type your question in here. I've noticed a couple of questions have been put in. We are really using the question function to identify you and get your name in the queue. And then once I get through these slides, Jim Martin, who's supporting us as well, will be putting that queue list up so you can see how long you have to wait before it's your turn. And so we'll be showing that shortly. But we want to make this virtual town meeting as close to an in-person meeting as possible. And so to do this, when your name is called by Amy, who'll be moderating the question session, I'll unmute you and you can ask your question. So we really want to hear your voice, and pretend you're in a gym and you get to stand up and talk in the microphone. If your microphone icon in the dashboard isn't green, you may need to unmute yourself. And if I see that you might be stuck, I'll just say, hey, so-and-so, you need to unmute yourself. Sometimes there's a little hiccup in there. Please state your name and your town of residence when you do come up, and you're free to ask the panel your question. Please note that when you are unmuted and speaking, DES and then all the other attendees will hear your voice, but you do not have video feed, so we'll not be able to see your face. So just to to kind of reiterate, and Amy might have said this at the beginning, is we are limiting your questions to about 3 minutes to ask your question in order just to stay focused and allow everyone's questions to be addressed. You know, if we're not going to like hold up signs and tell you to stop, but if we see that it's taking a few moments to maybe get to the point of the question, you know, Amy as the moderator might just kind of, you know, encourage you to ask the panel the question. We do want to keep this part of the meeting moving forward. Once you're unmuted and you can ask your question, if you have a follow-up question relevant to what they just said, go ahead and ask that. You know, again, if we were in a gymnasium, we wouldn't take the microphone away from you and not let you continue speaking. So we do want to encourage that conversation if you do have a follow-up question. If not, just let us know by saying thank you or you're all set, and then that'll let me know that I need to mute you. But I will not mute you while the panel is answering their questions. So we do ask that you just be respectful while the panel is responding. If you do have another question, you can go into the question box and put your name back into the queue as many times as you'd like. The panel is here for you tonight, so we want to answer your questions. So do not hesitate if something else comes up or somebody else hasn't asked it to go ahead and put your name back in. And so here's the how-to that Amy showed earlier. Again, I can see that some of the questions are coming in, so some of you have already probably figured out how to do this. But you know, again, if you do not have the dashboard showing, it might be minimized on your toolbar, or you might have to press that little orange arrow at the top to expand the dashboard. And once you do that, you'll see the question box. It is enabled and turned on for you. And then you just go ahead and put in your name, first and last name, and town of residence. Again, please don't type your question. It just will start to get confusing on how we're going to manage this with the panel. And then press send. And then Jim Martin will be showing the, I'll actually just move him over right now. We'll be showing the queue, and you'll be able to see your name in that list. And just be patient as we kind of get names and the muting and unmuting. I have to sift through all the attendees to find your name. So we just ask you to be patient as we get through this. And we hope that, you know, we can get through all of the questions and that you really leave here with a bigger understanding. And, you know, like we said, we're here for you. You have a panel of experts who can answer your questions. If you think of something offline, all of these resources and the handouts that Amy included with the webinar are available to you, as well as this recorded session. So hopefully we will get all the information to those who need it. So I am going to move over and I think I can get Jim up. There we go. So Jim, I've made you the presenter so you can share your screen. There we go. All right, and you can see that Jim started the queue already. And we'll just give it another minute, but you know, the panelists, once you are back, if you could just turn on your cameras so we know that you're here. There we go.
All right. And while we're waiting for the panelists to come back on, and we'll give everyone a chance if they want to get their names into the queue, into the question box, I do just want to once again reiterate that in the dashboard, there are 5 handouts that were added. One of them is the slide presentation from tonight with the instructional slides taken out. So just the pertinent slides are in there. There is a list of accredited laboratories that do PFAS analysis. There is a PFAS sampling instruction guide for homeowners if you did want to take your own sample. There is the PFAS in New Hampshire well water fact sheet that Brandon had mentioned in there as well. And then the 5th one, I put together about 95% of the links that are in the presentation in a separate document with everybody's contact information. It's a 2-page document. I figured it would be a little more unwieldy for you if you didn't have to scroll through the whole entire presentation to find pertinent links. So that is there for you as well. So you can save those off the GoToWebinar platform tonight, or like I said, tomorrow or Saturday morning, you'll be receiving a follow-up email that will have a link to all of these documents, as well as the video recording once we get that up there as well. So the video recording might be more Monday or Tuesday by the time we get it posted, but it will be there eventually for you. All right, do we have everyone at the panel? I do believe. Erin, do you want to be on camera or no?
If I get asked a question, I'll come on camera. Otherwise, I'm just going to be searching names.
Okay. I do have a few questions that we are commonly asked that I'm going to pepper in here as well. So I will start with one of them before we start the queue, just to get everybody prepared, and if there's anyone else that wants to put their name in the question box. So this is kind of a triple part question. How often should your well be retested if you have PFAS exceedances? It would be every 6 months or a year. And would you expect a change in the PFAS over time? And if the source of the contamination is solved, how long would it take for Pifoa to dissipate from our well water streams? So I open that up to the panel.
So I guess I'll take a stab at answering this from the perspective of inside the consent decree and where Saint-Gobain is sampling. So in the case of the widespread sampling program that Saint-Gobain has initiated, if a well tested over the ambient groundwater quality standard, it's sort of in queue for alternate water, and we'll continue to receive alternate water until such time as sampling shows it's below standard. And I believe one of the questioners mentioned a test result in the 35 parts per trillion range for PFOA. And in a case like that, some of the limited or wells that have been sampled several times over the course of the few years that we've been investigating Saint-Gobain, a concentration like 35 parts per trillion stays relatively constant. It might jump around a little bit, but I wouldn't expect it to necessarily clear up in years or time frame. Also, was there a second part to that, Amy? That question?
So it was, how often should they test their well? Would you expect a change over time? And if the source of the contamination was solved, how long would it take for Pifoa to dissipate from your well water?
Yeah, so I think in the case of PFOA, it's in the Saint-Gobain area, it's anticipated it's going to be there for a period of years, possibly decades. There's been some modeling done on that, but there's a lot of assumptions in the modeling. But I think the current data set that we have, which is limited, suggests it's going to persist for some period of time. In the other case, I will mention that Saint-Gobain is resampling wells that tested below the standard but close to the standard. So currently they're retesting wells that had a concentration between 10 and 12 parts per trillion for PFOA. The DES will be reviewing that data, and if the data suggests that there is variation in those water supply test results, the criteria for expanding resampling may expand. So that's all I have, Amy. Thanks.
All right. Does anyone have anything else to add?
I'll just comment on if you have a treatment system for your well, you really need to really look at what it's been sized for and what your contamination level is to kind of assess. But if you're treating for something like PFAS or arsenic, I think you'd want to sample for at least once a year. If you're on your own doing that work, it's very costly for a homeowner. Ideally you do it more if you could, but at least once a year. The filters like reverse osmosis have an indicator on how well the filter's performing, even though it's sort of a surrogate. You can measure salinity before and after the reverse osmosis, and that kind of gives you a sense of the efficiency of removal. And there's simple devices out there that can help a homeowner get that low cost salinity instrument and keep track over time of the treatment performance. You know, a recommendation though in general for private wells where you don't have this man-made contaminant and you're dealing with the natural contaminants is that you sample annually for bacteria and nitrite, things that can cause health problems in the short term and serious health problems for susceptible populations. And then every 3 years for the other constituents. But again, that's outside of an area where you have a man-made source of contamination. And so with the man-made source, you'd want to do more frequently.
All right, then we're going to go ahead and start the queue. So Leah Thomas, you are first on the list. So Erin, if you could unmute Leah.
I think they have left. So if Leah is still here or under another name, if she could raise her hand, but it looks like she's left. I cannot find her in the attendee queue.
Okay. Then I will move to the next one. And Erin, if you see her pop up, just let me know. So we're going to move to Maria Tomolonis. So could you unmute Maria, please?
Yep, she's all set.
Hello.
Hello.
Hi. So I have a couple of questions. I hope that's allowed. I'll keep it short. So the first question that I have is if residents of Bedford feel that they lay within the zone of requiring testing, who should they contact regarding that? So for example, if your neighbor got a letter in the mail and you look at the map and you look like you're within 500 feet of a well that is positive, is there somebody that you should be contacting regarding that for testing?
Jeff, do you want to take that one?
Yeah, I'll speak to that. So if you live within the blue outer boundary of the consent decree area, I would recommend reaching out to myself, and my contact information is going to be presented in the slide deck or in the links at some point. So I would be the appropriate person to address that. If it's outside the consent decree boundary, then Amy Doherty would be the person to reach out to about getting a well sampled.
Okay, thank you. So the other question that I have for you guys is, are these compounds additive? So if, for example, somebody were to find that their total PFAS, so PFHXS and PFOA, for example, were together higher than a certain number, would that also require you to do some sort of treatment to your water, or are they not additive? Are they just individual? I guess I don't know how to better phrase that, but.
So I can try answering that question first, and then if anybody wants to follow up on me with that, they can. So some states have looked at these chemicals, and because of a lack of information, they've grouped them so that if you think of the states like Vermont and Massachusetts, they have taken that combining approach. We looked at the evidence, and the way that they affect the body are differently. They have similar effects on some organs in the body, but we picked the most sensitive endpoints for each of these chemicals, which differ. So that means we're looking at them individually. So in our situation, that's how we're looking at these separately, is based on what's the most sensitive endpoint for each of these chemicals. They could have some additive effects. They could also compete with each other and sort of play down each other's role. This is something that's really being studied right now. But just from a general environmental health perspective, we also, again, as Brandon mentioned, we try to consider what are the other chemicals that you might be exposed to in your well. So things like arsenic and other naturally occurring contaminants. So we typically set low, very protective standards for these individually, and that's what we've done in this case. So I don't know if anybody wants to follow up on that as far as regulation goes.
I think that answered my question, unless somebody else had something. I have one more question. So there was a slide that explained that there are filtration put on the exhaust at St. Gobain, basically like a source control for the PFAS. And it said that that is going to be occurring, but has not happened yet. Is there a reason that source control hasn't been obtained yet, where this has been going on for many years? Is there a reason for why they haven't been compelled to, stop this from continuing to occur? It seems like that would be maybe one of the first steps.
Maybe I can take that for you, Amy. So I'm Kathy Bean from the Air Division. The facility itself had emissions of Pifoa at a much higher level back in the early 2000s, and they reformulated and reduced their Pifoa emissions then. That was all regulated by our state air toxics rule. In 2018, the legislature passed a new statute that required air emissions that impact groundwater above the standards that we've been talking about tonight to require them to put on control technology. And it has a time frame within that law in terms of application and permitting and installation. So that has been going on. The law went into effect in 2018. The application came in 2019. The permit was issued in 2020, and they were required by the permit and the statute to have the controls in by this past February. You may have heard that they failed to do that, and the state settled the issue with a consent decree requiring the installation by this July with some additional requirements on St. Cobain. So that's really the time frame of how this control equipment is being installed.
Okay, thank you.
All right. Thank you, Maria. I'm going to move to the next person in the queue, but if you do have any additional questions, please feel free to put your name back in the question box.
Thank you.
Yep. So we're going to move to Mark Ilaria. Erin, if you could unmute Mark, please.
Yep, Mark is unmuted. He's ready.
Hi, and I really appreciate you putting this together. I know it took a lot of work. I saw you at Peter Woodbury years ago when you first gave the talk. I think this was much better. My question is kind of a general question. I do have some knowledge of this. The EPA still has not set an MCL for this, and they have an action level of 40. The state has made this 12. And I just, think about what that does to everybody. It gets everybody, upset, excited because they're over the limit that was set up by the state. What if, I just am questioning what are the health effects if this has been really well documented, that level is really detrimental to health. From things that I saw, work was done where these were manufactured. So I'm really questioning that. And what if the health effects are found that at that level, it doesn't affect you? So I'd like to know about that. Will they change? I know it'll probably take an act of what has to be voted on by the state. So that was my first question. And my second question is, now what happens if we find 13 in Massabesic? Okay, so does that mean the entire town of Manchester has to shut down and go to bottled water? So I'm questioning about the limits that were put together. I know this bioaccumulates, but I'm just wondering about it because it's got a lot of people now doing a lot of work, and yourselves included.
So I can take that first half of the question, and then I'll let the question about Massabesic and general detection go to some other experts in the group. So the first piece of, our state set a lower standard than what the EPA is currently set. And a key thing behind that was meeting our legislative requests to evaluate risk for the most sensitive parts of the population. So that includes pregnant women, fetuses, and breastfed children. The EPA's current standard primarily focuses on a lactating woman, but it doesn't account for how these chemicals can build up inside of a lactating woman's body and then actually transfer at very high concentrations, higher than what's in the drinking water, through breast milk. And in New Hampshire, we do have a significant portion of the population that does breastfeed. There are a lot of benefits to breastfeeding. We still encourage breastfeeding because it protects against a lot of the concerns we might have with PFAS. But the idea was to meet our legislative request to protect the whole population. So for some segments of the population, a standard of 12 may be overly protective. But if you're thinking of women who are in their childbearing years and plan to have children and plan to breastfeed those children, that's one of the reasons that we reduce these standards to that lower level. So it may be overprotective for some, but for the most sensitive segment of the population that could accumulate a very high body burden of these chemicals and keep that throughout their childhood, we took that step in our risk assessment and recommended those lower numbers for that reason. So that's why we have a lower number than 70 or 40, depending which one of the EPA numbers you're referring to. As far as the health effects go, there are a lot of studies, and this is a constantly evolving area of science. There are some studies that suggested effects occur at even lower doses, but some of these were really poorly designed studies, or they didn't account for other things in the environment that people might be exposed to. Also, PFAS are a group of chemicals that are being studied around the world, and that was one of the things we tried to account for when we made these recommendations, was really looking for where do we see health effects, where are these consistent, and where might be people be crying wolf. And we tried to avoid that situation. So there are a large number of studies. If you want to go back in the slides, we did prepare a whole report with references at that time. We're also continuing to follow the science behind these 4 compounds and other ones to determine if there's evidence to develop standards or protective guidance around those. So with that, I think I'll open it up to anyone else on the panel that wants to add to that.
I'd be happy to talk about, the impacts to water systems. And the question referenced, what if Massabesic, the source of water for Manchester and many other communities via Manchester, was over 12? Well, first of all, it's very hypothetical because we know Massabesic is well below 12 parts per trillion for Pifoa and even lower for the other PFAS compounds. So that's hypothetical, and there isn't an exceedance concern. The MCLs that we've adopted in New Hampshire have really helped the New Hampshire water systems and the public. And what we've done in New Hampshire has been sort of supported really by the other states that have also taken the lead ahead of EPA on this, and that our standards are very similar in New Hampshire, very similar, not identical to those in New York and Massachusetts and Vermont. And so, we know, we're in the right ballpark. Now that we have a value, we've adopted as a standard, just not as some number on a website, a guideline, but an enforceable standard. Water systems are sampling for it. And when there's exceedances, a couple of very important things happen. First and foremost, the public was told that they're being exposed to a man-made contaminant that they would not have known about had there not been an MCL. And so they're told about it, they're told about the concerns and actions they can take in the short term until the water system corrects the problem. And already in New Hampshire, not Manchester, not Massabesic, but very large sources of water have been found to have contaminants, impacting over 200,000 people on public water systems in the state. And very important actions have been taken to turn those sources off and use other sources, to put in treatment, to blend, and to start figuring out the source of contamination and addressing it. And so while it is causing a lot of work, the work seems to be supported by the work of our peers in other states. And no doubt we're identifying and eliminating exposure every day. We're working on it, both the public water systems and with the private wells because of these standards.
Okay, I think I understand where you're coming from. It's just, I'm just wondering, the EPA, the Safe Drinking Water Act and everything they've done, I thought it's all fabulous work. I'm just surprised they're not coming out with a statement, something like what New Hampshire and the surrounding states have come out with.
Well, I can speak to EPA a little bit. From a drinking water standpoint, in March, they made a final determination that they're going to regulate 2 compounds, PFOA and PFOS. And there's a long process, the Drinking Water Act, that I'll spare you on, but I can send you a whole presentation on that, or even do a sidebar presentation someday on it. But they now have 2 years to propose that standard for PFOA and PFOS, and that's just to propose it. And then once they propose it, they have another 18 months to actually start the rulemaking process. All the while, there's public comments, possible changes in administrations, and it is the sole discretion of the EPA administrator, political appointee, to actually make a standard. And while EPA has been just fabulous in providing us scientific support with PFAS and everything else that we do, the last man-made contaminant that they've made an MCL for happened in 1995. And so it's a difficult process at the federal level to make an MCL for a man-made contaminant.
Okay, yeah, that's a good point. I get it. I get that for sure. And I know you folks have done a lot of work with this. I think you've done a good job with it. And I get it, that you're just really protecting the most vulnerable because of the bioaccumulation, right? That's basically it.
Yeah, and this is Mike Wimsatt. I'll just sort of close the loop on your question. One of the things I think you asked was, do we ever, if we learn that, a contaminant is perhaps less toxic or less poses less risk than we originally thought, do we increase the standard? Do we raise the standard? And the answer is yes. It doesn't happen often, but there are examples of where we regulate certain contaminants and new science comes along that says, it turns out that the information we had before was incomplete or erroneous, and at some level the level of toxicity is less than we thought it was. And there are examples where we have actually raised the standards based on that new data. So there are provisions in place to do that when the data indicate that it's appropriate.
All right, thank you, Mark. We're going to move to the next in line, and that will be Ann Remus. Erin, could you please unmute Ann?
Yes, Anne's unmuted.
And you can go ahead and ask your question.
You might just have to unmute yourself and your microphone. It says you're self-muted. There you go. She should be all set.
Thank you. First of all, thank you very much, all of you. This has been very, very helpful, and obviously you're very knowledgeable and you've done a lot of work. I also want to say thanks to Mark, the last questioner, because I thought he asked good questions that I had and got good answers from you guys. I have two questions. Speaking as one who's a so we are over the limit. We're in the consent area. I'm trying to figure out how to go about mitigating. And so I have two questions. The first thing is, what information or modeling do you have about how long we might have been drinking affected water? It is affected now, and the question is, we've been drinking this water for a long, long time. Do you have any modeling or any studies that give you any information about how long, this is a very personal question, how long our bodies might have been taking in over these chemicals?
So, Mike, do you want to respond? Or?
Well, tell you what, I'll open up, Jeff, and then I'll turn it over to a real expert.
Sure.
So that's a great question, and I think it's probably one of the most frustrating questions that there is, because we don't have a great answer for it. We are aware that around about 1985, we believe that ChemFab began operating that's the predecessor company to Saint-Gobain, that began operating this kind of a manufacturing operation at this Merrimack plant. And every reason to believe that these compounds were put into use at that time and that they were emitted. So we have reason to believe that there were emissions like this dating back to 1985. What we don't know is what the magnitude of those emissions were, or how long it might have taken for the phenomenon that we've seen, which is that air emissions fall out, as Jeff described in his presentation, and then leach through the soil and impact groundwater. So reason to believe that it would have started on or around 1985, but what the ramp up in concentrations, how long it took to get to drinking water wells, it's really hard to say. And Jeff, I'll turn the rest over to you.
Thanks, Mike. And yeah, I'll echo what Mike said, that the operations began in the mid 80s. I know there was a reformulation of the chemicals that were used at the facility, and this occurred, I think, in the mid 2000s. So I think by some estimates, the peak emissions of PFOA were in the early 2000s, and then it dropped off from there. I know Kathy has presented slides that show this previously. So I think it's fair to say that these have been in the groundwater for some period of time, and quite possibly decades.
Okay, that's helpful, although unsettling. So we have lived in the same house here since 1984, and I'm a huge water drinker. And I won't get into personal health issues, but it is satisfying to me that you guys have chosen this lower number this was part of your answer to Mark before me, but I feel like as well as the childbearing age population, people like myself who've been drinking the water for close to 40 years, it's kind of nice to know that at least the level has been set at a lower level than the national level. So thank you for that. The second half of my question, I apologize if you already answered it and I wasn't paying close enough attention. I know that we can now apply to have water delivered, I guess. The question is, can we get reimbursement for plumbing, for the plumbing solutions that were mentioned?
So I get this question pretty frequently from residents, and if you're within the consent decree area, so the area that Saint-Gobain is investigating, they've sampled your well, and they've offered bottled water, you could elect to install something on your own, like some of the systems that Brandon described, but the state can't compel Saint-Gobain to reimburse you for action that you've taken on your own. So that would be a matter between you and Saint-Gobain to, try to come to some reconciliation on. But, from the state's perspective, we can't force Saint-Gobain to reimburse you for plumbing changes. But that being said, Saint-Gobain is ultimately responsible for providing a permanent remedy to your well.
Okay, and so if I have privately tested the water, and we are in the consent decree area, and we have tested the water and we are over, would Saint-Gobain also want to come out and separately test the water? Or do they take, for example, Nelson Labs' results?
They'll accept the lab results from other laboratories. In some cases, they may choose to take another sample, but they'll start providing bottled water generally upon receipt of those lab results. So if you haven't already transmitted them to Saint-Gobain or to DES, you can reach out to me offline, and I can talk you through the process of getting those results to Saint-Gobain if you haven't done so already.
Thank you, Jeff. I haven't, because I've just recently learned this, so I will be in touch. Thank you.
Thanks.
Yeah, and if I could add to that, Jeff's got that exactly right. The one thing I'll say to augment that is, and Jeff touched on this, is that when the state negotiated the consent agreement with Saint-Gobain, it was not negotiating on behalf of individuals or anybody else. It was negotiating essentially what its authorities would be and how it would address these various things with the company. So what that means is that while under the consent agreement, they would be complying with the agreement by providing you with alternate water, with bottled water in the interim, and then eventually providing you with an permanent alternate water source. But if that does not preclude you from contacting them directly to try to seek whatever it is you might want to seek from them, that it's not as though the consent agreement limited your ability to negotiate directly with the company if you chose to do that. So I just want to make sure that everyone understands that.
Great, thank you.
All right, thank you, Anne. Again, if any of you have any further questions, please feel free to put your name back in the question box to be added to the bottom of the queue. But with that, we're going to move. Okay. We're going to move on to George. And George, I apologize. I don't want to butcher your last name. So, so Aaron, if you could unmute George, please.
Yes, George is unmuted.
Okay.
Yeah, George Hadzioka, just pronounce every letter, no silent Q's.
Thank you.
So one of the things, this only became an issue for me once I got a letter from DES saying my adjacent neighbors had elevated levels. I mean, there's more I'll ask offline and stuff, but a couple of things. One is PFAS, the PF, or polyfluoro. All these compounds are hydrocarbon chains with fluorine atoms attached. So that's one thing. I wonder if you can comment on that versus say, fluoride, like sodium fluoride, where fluoride compounds are in some municipalities are intentionally injected into water systems. Because I noticed that there's almost 3 orders of magnitude difference in water quality acceptable levels between fluoride itself and PFAS.
So I'll start on that, I guess. Right, no, that's a great question. And this is something, you know, my original training is as a chemist. So this is a source of frustration for chemists, is that the structure matters, and the molecular structure really matters. So I guess an example I would give that is maybe more familiar to people is that, you know, what's sodium chloride? That's chlorine, right? And that's something we all know, it's salt. But we have been, you know, those of us on this call here before PFAS came along, spent a lot of our careers chasing organic chemicals that contain chlorine. That have contaminated groundwater and all around the state, you know, things like dry cleaning fluid or chloroethylene. So very sort of analogous, and those organic chemicals with chlorine can be very toxic and can cause cancers, and they're well known, and it's very well demonstrated that they're poisonous. But we don't think of salt as being poisonous. So I think that's a very straight analogy between the chloride and salt and the chlorine in these organic chlorine chemicals, and the fluoride in, you know, toothpaste, if you will, and the fluorine in these perfluorochemicals. So it's very different, and it's not, you really can't draw any parallels in terms of toxicity just because fluorine is involved in both of those. When it's fluoride, it's very different than it is when it's a fluorine attached to a carbon chain.
Okay.
Does that answer your question?
It does to a degree. I still you know am of the opinion that if I'm on a well system right now, if I was on town water, I still wouldn't like the idea of additional compounds being injected into the water because someone other than me thinks it's beneficial for me. But that's like a separate issue. But I understand, yes, the difference between the different you know, molecules containing fluoride versus a simple compound like sodium chloride. The other thing was regarding the maps. So you do have like maps where you can kind of like look at water tests that have been done. You know, you've got the green dots, the red dots, the orange dots indicating the amount of PFASs that were detected. They appear to be static. I was wondering if there's like a similar map for air tests, and additionally, if there's static and dynamic maps. In other words, like, is there information available that has this info tracked over time?
I'll answer the second part of your question. I think in my GIS that I use in the office is a little more powerful, so I don't know for certain, but I think if you click on some of the sample locations, you might notice that there's like a number 1, 2, and 3, sometimes up in the upper right corner, and that if you click through using the arrows, you may be able to get to multiple samples for the same location. But I will point out that the vast majority of locations on the map that were sampled for groundwater have only been sampled once. So there's not a lot of dynamic data out there. I have been tracking some of that data. In fact, Saint-Gobain's consultant Golder Associates just uploaded to One Stop an entire report on several wells that they have been tracking through time, some as far back as 2016. And so that's probably the best data set tracking PFAS in this area over time. So I'd refer you to that report. It's on One Stop, and I think one of our handouts probably directs you to that location.
Yes, sorry, the link to that is that in these slides, or is it elsewhere?
Amy, is that on the handout, do you know, to One Stop?
There is not a link to One Stop, no, but I can add it and get it up onto the Dropbox for everybody.
Great, thank you.
So in one of your slides today, you basically have like a overlay of several things like air test and stuff like this. Is there an air test map? And are there air tests still being done, like air sampling of PFASs or PFASs rather?
Right. So the map that Jeff put up was what's called a modeling map. It shows modeled a computer simulation of historical air emissions and where they may have landed in the area. And we have maps for historical emissions based on a computer model that are on our one stop as well. And I can certainly get those links to Amy as well if you'd like. In terms of stack testing, like actually at the facilities, first of all, the methods for stack testing are in development. There are some proposed ones out from EPA. They are not certified or official stack testing methods. They're very different than the standard stack testing that we do. We have done some testing at St. Gobain over time. So we do have stack test results, but they're not mapped out like the water results are. And then in terms of, I think you mentioned just air sampling, and I don't know if you mean what's in the ambient air just out in the atmosphere. That has not been measured as of yet. So.
Okay, so you've done modeling, but not actual testing on the what would have been, say, dispersed through the air.
Right. There is no method for doing sort of an ambient sampling like we would for other things like the smog or ozone that you would commonly refer to in the air pollution world, in terms of having a way to monitor the levels in the atmosphere. PFAS being such a new compound, an emerging compound, standard methods have not been developed yet for doing that.
Okay. All right. Thank you very much for that. By the way, this has been an extremely informative presentation. I appreciate your efforts in the detail that you guys have been presenting. It's pretty awesome. Thank you.
All right. Thank you, George. We'll move on to Michael Chen. So Aaron, if you could unmute Michael and he can ask his questions.
Michael's all set.
Okay, hello. Thanks again. I really appreciate this as well. My question is about the consent decree. How can we find out more about what St. Gobain is responsible for doing under this consent decree? So what our situation is we are inside the consent decree boundary, and our neighbor had tested above the limits and was, offered water from St. Gobain. And as I understand, since we're within 500 feet of our neighbor, we should be getting our water tested as well. And when we contacted St. Gobain, Golder came back and said that they agreed that our house is in the consent decree area, but our house wasn't flagged for testing and they weren't going to do it. So I guess the root question is, where can we find out more about St. Gobain's obligations under this consent decree so we can better assert what we think is coming to us?
I think I missed one or two words when you said why St. Gobain denied testing, or why Golder said they weren't going to test your well. Could you repeat that?
They said our house wasn't specifically flagged for testing, and they left it at that. So we didn't know what to make of this, and this was like within the last week, and so I just wanted to wait for this meeting to make sure that I was informed, and so to continue, me being informed and being able to, ask or request this this testing, I'd like to know, I guess, what is in this consent decree? How can I find out more specifically about what they're responsible for in this consent decree so we can advocate for what we need?
So I guess one thing, one of the slides that I showed had an excerpt from the work plan for sampling wells that Golder submitted in September 2018 or 2019, I'm sorry. And that's available on One Stop, and we should probably include a link. I guess that's another link I could add to Amy's list, a link to that document, because that basically lays out how Golder is going about this sampling program. I could probably follow up with you offline and look at the specifics of where your property is in relation to other samples, and we could probably run this to ground offline, because it probably boils down to where your property is located. But I think, as Mike mentioned earlier, so sort of in the I guess the donut hole outside the pre-GMZ, like the state's regulations pertaining to site investigations apply in that area. So it basically falls to the ENV OR 600 rules, and you know, we could provide a link to that, but it'd probably be easier just to follow up offline on the specific instance.
Okay, that's fine. Just to make sure that I got just the basics right. Is it true that that we should be getting water tested from Saint-Gobain because our neighbor was within 500 feet and they tested above? Is that so? Is that much true?
Yeah, and I guess it's also important to point out that, you know, they are doing this large area, so you know, it's hard to speak for them and what they meant by their response, but in DES's view, any well within that blue line should eventually be sampled, but you know, it's based on risk and proximity and timing of sampling. So, you know, I'm not sure really what they were trying to tell you when they said, you know, you weren't flagged for sampling. Maybe it meant that you haven't been identified in any of the addenda that have been submitted to DES. So it's certainly quite possible your property may very well be listed in the forthcoming addenda 9, which is expected by the end of the month. Which they have said that they are going to be using a 500-foot buffer around an exceedance. So if your property is within 500 feet of a well that tested, I would expect it will be included in that addendum 9.
Oh, okay. So it could just be the system hasn't caught up yet.
Yeah, that might be. The more I think about their response, right. That's probably the case, and it's you know, probably not them telling you they're not going to sample your well. I you know, haven't really encountered anything quite like that yet, except in a few very minor examples.
Okay, thank you.
All right, thank you, Michael. We'll move on to Terry Humphrey.
Terry
Hi.
is unmuted.
Great, thank you. And thank you very much for setting this up. Like everybody else has mentioned, it's been very informative and it's really appreciated. I have two quick questions, and one is, if the emission control on the plant in Merrimack is just being installed now, do you anticipate the numbers to continue to go up in that kind of blue consent area? We've been tested once about 18 months ago or so, and you know, our concern is that the number we had, which was fine at the time, will be drastically different based upon that.
So, you know, I think the addition of the emissions control, I wouldn't expect that to cause an increase in groundwater concentrations within, you know, the outer boundary of the consent decree area. But that being said, there could be other reasons why the concentrations may fluctuate over time. And from the limited data set that we've looked at, which is about, you know, several wells that have been sampled more than once, is that in cases where the groundwater fluctuates up and down, there may be some changes to concentration of PFAS, but we've also seen wells that almost don't change at all over time. So, you know, it's difficult to predict how any well will vary, but that's something we're certainly looking at as additional data come in. The report I mentioned that Golder just literally in the last few days uploaded to DES, and the resampling effort going forward to see what kind of changes we're seeing in the groundwater and what sort of trends.
Okay. And then my second quick question is, should, as a homeowner, we be concerned about a well that's within, say, 100 to 200 feet of a body of water like the Riddle Brook, which runs through the Bedford landfill, which you've already outlined as a, you know, kind of somebody who has exceeded the state minimum levels of acceptability? should there be concern that some of that water would leach into the groundwater that may end up in our well?
Amy Doherty, do you want to take that, or would you like me to take that?
I think if we're talking, can you hear me okay?
I can.
I think if we're talking about the surface water samples that have been collected down gradient south of the Bedford landfill there, first of all, we don't have surface water standards currently, but PFAS has been detected, the source of which is still under investigation. It's not entirely clear that it's sourced at the landfill, but it is being investigated. And I think when we become concerned about wells around impacted surface water bodies, we're particularly concerned about wells that are shallow, dug wells, or wells that appear to be directly connected to those surface water bodies. And that's when we get concerned, particularly. Sometimes if you have deeper drilled bedrock wells, they may not be connected to those shallower surface water bodies, so they may be lower risk. So we approach each one of those situations at a risk-based level. But you're right, there has been PFAS detected in that brook, but the source is unclear at this point.
Okay, thank you.
All right, thank you, Terry. Sandra Klang will be next. Erin, could you unmute Sandra?
Yes,
Sandra
hi,
is unmuted.
Thank you all again. This has been very informative. My question pretty much was unanswered but answered, in that I wanted to know about air quality and if anyone knew, what the regulation was for PFAS in the air and sampling and whatnot, because inhalation does contribute to the toxicity of the PFAS. And does anyone know how long the PFAS can remain airborne? Is it, a year till the next rainfall? What happens there?
So I can speak a little bit to that in terms of air inhalation standards. We have a state air toxics rule directly associated with inhalation. However, the majority of these PFAS compounds are not listed on there because there's not enough studies to produce standards for that inhalation level. One of the compounds, Pifoa, in its acid form, is on the list, and that is the standard that resulted in an action that the department took against Saint-Gobain in 2005 to reformulate because of the levels that were exceeding the inhalation standards at that time. So they reformulated away from the Pifoa raw materials that they had at that time. In terms of current emissions, they are not emitting any PFAS compounds above any inhalation standards that we have, because there's very limited studies to have very many standards in that regard. In terms of how long they last in the air, I'm not sure we have studies on that either. PFAS compounds can be a lot of different things. They can be vapors, but they can also be particulate. They've been found, quite a distance away from facilities. So it's very hard to say that any one particular PFAS stays in the atmosphere longer than another one. I don't have much knowledge about that.
Okay, thank you.
Really quick, I'd just like to add on, as far as the exposure that goes, a lot of the studies have heavily focused on dust particles and things like that indoors that contain these. In general, when it comes down to chemical contaminants in the environment, this is just blanket advice that we always try to recommend is, if you have an in-home air filter of any kind, changing that regularly, sweeping, dusting. I know it sounds very bland and sort of boring advice, but there's other chemicals that can be carried that way. And that's one of the sources of literature or information that we also study for PFAS, is that same route of exposure. So as far as like a method to actually reduce your exposure, their air concentrations may be difficult, but we know dust can carry a lot. So if you can reduce exposure to that, or just reduce the amount of dust, because again, those in-home products can also contribute to exposure, plus things from outside of the home. So just as an overall way to reduce risk and exposure, that's something I always like to remind people about.
Thank you. Yeah, the concern is more the outdoor air quality, and as the crow flies, we're 2 miles from St. Gobain, and so wanting to know pretty much what that impact is, inhalation as well as our well water. But thank you guys.
All right, thank you, Sandra. John Russell is next on the list. So Aaron, if you could unmute John Russell so he can ask his question, please.
Yep, John's all set.
Hello, thank you very much. I appreciate you taking my question. Can you hear me? Good. My question is a request for comment. Something I heard about a year ago was that for a relatively modest investment of maybe about 80,000, scrubbers could have been installed to have offset this entire problem. Long time ago, I actually did a degree in chemical engineering, and what I can share, even though I'm not a practicing engineer, not a practicing chemical engineer, is that there's a very rigorous discipline to chemical engineering. And it strikes me that corners were cut here, and this entire problem could have been offset. Now, the number I heard was 80,000 for an air scrubber system that could have prevented any such emissions. And it seems to me that, accountants got in the way here, management got in the way here, and, there's been a very significant impact to 3 major towns in New Hampshire. It just frustrates me that the lack of proper engineering discipline on the part of Saint-Gobain Performance Plastics has caused so much distress and anxiety, and including, all your expert time. Could you comment as to how this should have been avoided, what it would have cost to avoid? And bear in mind that Merrimack, the town of Merrimack, has just invested in a significant RO system to cleanse wells 4 and 5. And as I live in the Greenfield Farms development, we use that water system, and we greatly appreciate what the people of the town of Merrimack have done. They've borne that cost. So it seems to me there's an enormous cost being borne now versus a relatively small cost that should have been expended before to avoid this entire situation. Could you comment?
Well, I don't know if I can comment so much on what could have, should have been done. I can comment that there were catalytic abaters that were being used in Vermont that were not being very effective, that plugged quite quickly, and that may not have been sufficient for PFAS emissions, and that it wasn't until 2004, 2005, when stack testing became available to be able to detect these compounds, that it was even something of that we were aware that was coming from the facility. And at that time, we issued an order to them to reformulate because of that air inhalation standard that I talked about, our air toxics rule. Reformulation is one option that you can do under that rule, under that law. In terms of a scrubber system, I know there is one over in Vermont. Again, that just takes the air emissions and puts it into water, which then has to then be disposed of. So the proposed controls that they are putting on by the summer is a thermal oxidizer intended to break down these carbon fluoride bonds. So regardless of what kind of ambient quality, groundwater quality standards are developed, they should be capable with this thermal oxidizer of destroying all kinds of PFAS, not just the 4 that we have standards for. And I think that is probably the best, well, it is, in our opinion, the best control device for this situation.
Can you comment, sorry, Kathy, as to how long that solution has been available, and could have been deployed earlier?
A thermal oxidizer is a common device used for emission sources of certain volatile organic compounds, that sort of thing. At a certain level, we see them installed in many locations. In terms of PFAS, this will be one of the first facilities in the country that's used thermal oxidation to control PFAS emissions. And again, the law requiring this type of control because of the impact to groundwater went into effect in New Hampshire in 2018. The prior law that was covering this issue was the inhalation standards that I talked about that had them reformulate in 2005, 2006 timeframe. That has been on the books for 20 plus years, that law. So
Okay, thank you.
Thank you, John. Now we will move to Rick Sawyer, Bedford Town Manager. Could you please unmute Rick Aaron?
Yep, Rick is all set.
All right, go ahead, Rick.
Good evening, and I want to thank you all for being here tonight, and certainly invite you back soon and often for more updates. And part of when you might come back might be the answer to my question for you, which is probably directed to Jeff or Mike or both. Do you have any kinds of timelines that you can share with the community for decision making on permanent solutions within the consent decree area? When I look at the data, there appears to be obvious neighborhoods that need solutions. Will we be looking at pipes in the ground this year, or do we need to wait until all of the properties in the consent decree area are tested? What's the timeline, and what are the next steps?
So thanks, Rick. Yeah, there's a couple things moving there, and I'll turn it over to Jeff afterwards. But there is a process that Saint-Gobain is going through to sample and try to, on a prioritized basis, based on following the data, trying to get as much data to understand where the impacts are, to figure out where essentially, alternate water, probably in the form of water lines, or maybe in some cases where that's not practicable, point of entry treatment systems are indicated. So that's something that I think, we understand that they expect to have their, the latest we've heard from them is they would expect to have that sampling completed by the end of this year. Having said that, we are still engaged in a current conversation with them in places where we believe it's pretty clear that extension of a water line is appropriate, and there may in fact be a water line nearby, so that perhaps smaller targeted projects could occur more promptly in parallel with that sampling that's going on. And we're still talking with them about that, but it would certainly be our hope that one or more locations might be identified where that kind of work could happen more promptly. But with respect to a larger, waterline projects that would come out of this sampling effort, that's probably not something that would happen this year. It would probably be next year, I think. And Jeff, I don't know if you want to, augment that, or if you have any thoughts about that.
Yeah, no, I think you covered that pretty well, thoroughly, Mike. So Saint-Gobain has indicated that they expect this sampling program to be, substantially completed by the end of the year, at which point they can really start to plan the extent of the larger waterline extension work that needs to be done. And, recognizing that, when you engage in such a large expansion of a public water system, you start to get into other factors such as, do you need additional storage tanks and where do they go? So, I think to be fair that, you really need to identify the extent of where that water system is going to be. So there's necessity to complete that sampling.
Thanks again for your time.
Thanks for having us.
Yes, thank you, Rick. So now we'll move on to John Smith.
I think I have the correct person and I have unmuted them.
All right, John, go ahead and ask your question.
Can you hear me?
Yes.
All right, thanks. So first and foremost, thanks for being here. This has been great. Rick Sawyer really asked my targeted question is what's the timeline for Saint-Gobain to make remediations to the water? But in follow-up, the question I have is Saint-Gobain also responsible for people financially, for people who have been affected physically by this, right? So like, are they going to be responsible financially for people who have health side effects, or is it strictly for remediation to the water?
So thank you, Mr. Smith. That's a fair question. It's probably a question that is out of the realm of DES, in the sense that, the statutes and rules that we operate under are really focused on addressing the environmental impacts related to soil and groundwater and surface water contamination associated with release of a regulated contaminant. And the work that we do obviously also crosses over into drinking water very heavily, and that's where most of our efforts have focused on with respect to this. With respect to any damages or that might be, sought against the company for people whose health has been affected, that's not something that DES would we don't have any regulatory authority to influence that, and that's something that is really, I think, a legal matter between the harmed party and the company. I will say there's nothing that we have done with respect to the consent decree or any other efforts that we've made that influence an individual party's ability or legal authority or standing to take an action on that.
Thank you very much. And I would just once again thank all of you for all that you're doing.
Thank you. You're quite welcome.
All right, thank you, John. Next, we have Emma Carroll Parody.
Thank you, Amy. Thank you, everyone.
Hi,
Emma. Hi. I just want to say thanks to Rick for bringing that up, because I think something important to note, I'm living in an area that's surrounded by 3 homes that have been on bottled water for over 2 years now, and that hearing that there's no current solution for this community is very difficult to digest. I've received emails and concerns that they have been lugging Monadnock water to their homes for well over 2 years. And they're the numbers of 118, they're over 50 parts per trillion. So they've been affected for a really long time. So to hear that there's no solution currently is really disconcerting. A point of clarification I'm looking for. I understand when we talk about point of entry and point of use, I don't understand why one of the solutions is promoting a point of use RO filtration system when a lot of people I know interacting, and for those listening, I'm on the legislative commission with many of the people here. So this is just a question for clarification, because I see a lot of people in our community saying, oh, I have a reverse osmosis at my kitchen sink. And I always like to remind people, you use your water more than just your kitchen sink. So the question, I guess, is from whenever negotiations happened with Saint-Gobain and what they would and would not cover, why is a point of use promoted? And I also can talk about from past experience, I was part of the 61 homes that were connected to public water. Everybody on our street got a point of use Culligan filter at their kitchen sink. I opted to pay out of pocket for a whole house filtration system. Everybody else went with point of use because that's what was offered. I guess, I don't know if you can answer that, or if I'm just gonna make that a public complaint that it shouldn't be offered at the moment.
So thank you, Emma. I guess as you know, you're asking for a clarification. We've presented all the various options that are available for treating water here, and Brandon, I think, was trying to be very thorough in providing all the technologies that are out there. We don't necessarily view a point of use unit as a permanent solution of alternate water. Generally speaking, if we've got somebody who's been impacted by a responsible party who's contaminated their well, then bottled water or a point of use might be a temporary fix. But generally speaking, we would anticipate and expect a responsible party to either provide a whole house treatment, a point of entry treatment, or connection to a public water system as a permanent alternate water fix.
Okay. One last question. Actually, scratch that. I'm going to leave it to others, and I will chat with others offline. Thank you.
Thanks.
All right, thank you, Emma. We'll move on to Seth Wall.
Hi, this is actually Kim Wall. I'm just registered under my husband's account.
Okay, go ahead with your question.
So we have unfortunately been on provided water for over 2 years in our location. And I have to say that throwing that amount of plastic in the landfill is really disheartening. And even my kids who are very young know better than to be generating that much plastic. And we actually had to fight with Monadnock to get a 5-gallon reusable water dispenser to help eliminate some of that disposable plastic. So that's an aside. My question is, and perhaps this is for Jeff, we are on a road, it's Ledgewood Road. There's about 26 homes, 6 of which we know have been impacted. We're all on well water. However, the 2 roads adjacent to us are on town water. And Jeff, you mentioned that you're working with St. Gobain, and we've actually been in touch with Rick, who's been great, the Bedford town manager, to try to get Ledgewood Road on the list of roads to have the water brought in. Would St. Gobain be responsible for that expense and piping it to the homes as well?
Yeah, so good question. So if Ledgewood Road inside the consent decree area, yes,
it is.
So properties that are on roads that are, immediately proximal to water lines is what we had in mind when we sent St. Gobain a letter in December 2020, recognizing that this investigation was taking a long time, and partly it was delayed due to the injunction that Mike talked about from the Superior Court. But recognizing this is taking a long time, and there are this low-hanging fruit where a street with maybe 20 homes could be connected, or even lower hanging fruit are people that front water lines that have been tested over standard, and that'd be very easy to make that connection. So DES sent a letter to St. Gobain requesting a plan to identify which properties and where water lines can be implemented ahead of completion of the sampling program. But to date, they have not submitted anything in writing to us.
Now, would the homeowners be responsible for any of that cost, or would that be covered by St. Gobain?
So the cost to extend the water line, run the water line to the house, make the plumbing connections, and decommission your well, if you so choose, would be borne by St. Gobain. The cost that would not be covered is any future water bills, monthly water bills, or quarterly water bills.
Okay. Great. And when would we know if our road is being addressed? What's the timeline?
St. Gobain has said they're working on it, and we have a call scheduled tomorrow, and hope to have a more firm timeline presented to us. But at this time, I don't have one.
Okay. Okay. Thank you. I appreciate it.
You're welcome.
All right, we will move on to Sandra Klang, who has another question.
Hi, so Kim just actually touched on my question, but to take it one step further, and please bear with me because I'm just reading up on all of what's been going on for the past so many years. But my understanding is that in Litchfield, folks were forced to be put on the town water, and their wells needed to be done away with. But yet they are still incurring the costs for now the town water, and they weren't allowed to keep their wells for irrigation systems. And so they're now paying fees for water that they could have used from their well, but now that's coming out of their pocket. Is there any plan to have St. Gobain or whomever be responsible for those ongoing fees?
So yeah, so thanks for that question. So I want to explore a couple things you said about Litchfield. Actually, to be clear, nobody was forced. Nobody was connected to public water against their will. We gave, St. Gobain was instructed to give them the choice, and they gave them the choice. And if they connected, then they were, once they connected and they accepted a connection, they are responsible for paying their own water bill. With respect to, irrigation and keeping your own well. This was, to be candid, an area that we were very concerned about. In general, in the past, before we had this kind of a widespread problem before, if somebody were connected to a public water system, we would generally require that their well be decommissioned. And there have been some limited circumstances where the specific hydrogeology, we felt that that was the most appropriate thing to do. But in many cases in Litchfield and elsewhere, when people were connected to the public water supply, they were allowed to keep their own private supply well, and plumbing connections were made to keep it separate from their house water supply. And there are a number of people that kept those wells, and they're using them for irrigation. With respect to the latter part of your question, there is actually a bill in play in the New Hampshire legislature right now that would require that in a particular circumstance where a responsible party contaminates a well and then therefore has to connect it to a public water system, that the party pay for the water bill for a number of years. I don't know what will happen with that bill, but currently the way that we implement this, if the responsible party bears all the costs of extending water and making the connection to the home, then after that, the homeowner is responsible for paying the water bill unless they negotiate separately. In other words, DES is not going to impose a requirement that, and isn't in a position, we believe, to impose a requirement that the responsible party pay the water bill. However, an individual homeowner who gets connected is at liberty, if they wish, to try to negotiate or somehow work with the company to have their water bills paid. That's something that would be an arm's length from DES.
Thank you very much.
All right, thank you, Sandra. We will move on to Joseph Melly. Erin, if you could unmute Joseph, please.
He should be unmuted.
Go ahead with your question, Joseph.
He is unmuted, but we. Joe, if you're having technical issues, go ahead and type the question in the question box, and I'll read that aloud for the panel. We'll just give this a second and see if Joe can get his question in there.
Do you see anything yet?
Go ahead and try to speak again, Joe. I just saw you clicking through your microphone. No. Okay. So, Joe, we can't hear you. So why don't you type your question into the question box exactly where you put your name. And he said he'll call Mike Wimsat tomorrow.
Okay.
So thanks, Joe. Sorry we couldn't hear you. And then give me a second to get to Mr. Russell.
All right.
Okay, Mr. Russell, you should be all set.
Okay, great. Can you hear me?
Yes.
Yeah, great. Thank you again. Thank you to Kathy, especially for the explanation of thermal oxidation. I just took off and noted documentation from the 2018 era that on the solution. Here's my question. Maybe it's a dumb question. I apologize. But why was Saint-Gobain Performance Plastics permitted to operate, given that we first all got together in 2014? We started to discuss this issue, you know, at various towns in Merrimack and Bedford. And these guys didn't really have a technology solution to prevent emission of PFAS and PFOA. So given that we knew that they were emitting this stuff, and given that they didn't seem to have a technology solution, from what you were saying, that was really effective. Why was this plant permitted to continue to operate up until a point that, we actually had a solution that we knew would take these things out? Sorry, Kathy.
Kathy, you're muted.
Okay, yeah. Sorry. So when this water contamination was first discovered in 2016, there was no state law that said that they had to put on controls because of this contamination. That law went into effect in 2018. And within a week or so of that law becoming effective, the state sent Saint-Gobain a letter requiring that they put on controls. And the law itself has a 6-month window for application and then a 1 year from permit issuance to install those controls. And it allows for the operation of the facility during that time frame. So we've been following the law as it was written by the state legislature and implementing it accordingly. So there was no law on the books in 2016 when this was first discovered that required controls for that particular situation.
So basically what you're suggesting is that if there isn't a law, there's no way of stopping them from actually emitting whatever.
So we're a regulatory agency that implements regulations, and then if a regulation exists for a facility, we implement it. This particular regulation went into effect in 2018, and so we implemented it at that time.
But the fact that there wasn't a way of preventing these emissions, that doesn't kind of kick in some kind of, you have to stop?
I'm not sure.
Well, it almost feels like there should be a fail-safe mechanism. Like in normal process control, there's always a fail-safe. If something's going wrong, you have to stop. Does it require state law to stop? Because that's not fail-safe.
Yeah, Mr. Russell, you have a number of experts here that can answer a number of questions, but we didn't bring any lawyers with us. So this is, I think, a legal question that really is beyond the scope of the expertise that we have in the virtual room here.
Actually, I would argue it's a chemical engineering question. I mean, if we knew that we could measure these things, and we couldn't measure them, say, up to a certain point, and now we know that there's a problem, and we now know we're spending money. I mean, isn't there an engineering discipline that says you need to stop?
No, I don't think this is a question we're going to be able to answer for you.
Okay.
All right, I don't see any more names on the list. If you do have another question, please feel free to put your name in the question box for Jim to add you to the list. What I will do in the meantime, while we wait to see if there is any more questions, is I'm going to take control away from you, Jim. And I will share the contact information slide that is part of the handouts and will be in the email link tomorrow for anyone that's on here now and just wants to jot down some contact information or screenshot. So I will do that now. All right. All right. Can you see my screen? Yes, okay. And then Jim, if you just want to let me know if any more questions come in. I'll give it a minute or two.
I don't see any, Amy.
Okay.
While we're waiting for that, I would just like to thank Rick Sawyer and town government in Bedford and the people who have attended this evening for your attention this evening. This was a lot to digest. We took the risk of providing a lot of information because we thought it was important to give you all as much information as we could within the realm of not spending too much time talking. And I hope it was helpful, and I hope that our question and answer session was also helpful in addressing your specific concerns. Always happy to have people call or email to follow up on what we discussed tonight. So we'll look forward to that. And certainly we will plan to be back in Bedford. You know, in the meantime, you don't have to wait for us to come back and host a session like this. You've got a lot of contact information here where you can reach out to any one of us with your questions in real time, and we'll do our very best to help you. So thank you again.
Amy, can you just repeat where the recording will be and how people will be able to find all this information again? We're just getting a couple of questions about that.
Yes, so for all the attendees, there will be an email that goes out either tomorrow or Saturday morning. It's usually a day after the presentation. That will have a link in it, and that link will bring you to all the 5 handouts that are in the platform tonight and the video recording. I just ask that you give us a couple days to get the video recording up on that platform for you. It's probably going to be a very large file and it's going to take some time, but that will all be there. And then we can also share that link and the video recording with the town so they can post it as well for anyone that wasn't able to attend tonight. All right, Jim, do you see any other questions?
That's it.
All right, then I would also like to thank everyone that attended today and the town of Bedford for inviting us. And I hope that everybody has a good night.
Thanks, everybody.